Hello everybody and welcome in this new video tutorial. I know it's been a very long time since the last video and sorry for that. A lot of things happened in my life the last year. But what I wanted to share with you is a sort of guided tour of Unreal Engine 5 for not pure beginners, but for people that already have some basic knowledge of game programming coming from other engine or other tech. Or other techs, such as, for instance, let's say you already have made a game in Unity, or you know how to prototype in Godot, or maybe you are coming from Unreal, but you want to brush up on more, I will say, programming concepts and the architecture of the engine and how to actually develop some game systems. And the goal of this video, and as you can see, it's a long one. The goal of this video is to give you the clues and the ability to understand actually what you're doing and how the engine was made behind the scenes. We are gonna discover and deconstruct the third-person template. So we're gonna start by creating a new project starting from the template, and we're gonna try to understand everything that we can see on screen, from the input, from how the animation works, how the actual what is a player controller, how are the maths being computed, how do we rotate the mouse, the camera around the character, and all these things we're going to deconstruct and try to understand them and see them in the engine. So why I want to do that? It's because I don't want to do a tutorial such as, oh, and now you use this function from the engine and it's magical and we don't understand how it works behind the scenes. I want you to understand why the engine is made like that and why it works. Okay, so you will have a better understanding on how to develop your own features following good practices, good Unreal Engine practices, and also you'll have a better understanding on how the gameplay framework from a dev perspective works. We are also going to learn about basic editor knowledge, so such as how to move in the viewport. I'm going to share a few tips and tricks that are quite important, I think, when you're using the engine professionally. I'm going to share with you basic knowledge about animation blueprints, basic knowledge about materials, and we're going to discuss, again, programming concepts. We're going to enhance the templates by doing a pick, picker, a grabber like this, where you can grab objects. We're going to discuss, in order to do that, about the physics handle component. We're going to discuss about how to make our own components. We're going to discuss about interfaces. We are also going to discuss about delegates. You can see here we have like sort of spawners, where not spawners, but places where we can drop objects and it says that the bucket is complete. We're going to see how to architecture, I would say, good code, but not it's not going to be a fully production ready code, of course, but this is already going to give you good practices and how to don't repeat yourself and how to use proper patterns in order to develop some features. And we're gonna slightly discuss about UI. As you can see, we have a crosshair in the center, and basically lots of things that will hopefully give you the keys to start learning this engine if you already have basic knowledge about game making. Okay, maybe you're gonna learn a few tips and tricks that you can put in your tool bag as a game maker, but that's my goal. Okay, we're gonna discuss also, of course, about blueprints and more things along the way, but I hope you will have some fun following this video. I know it's gonna be a pretty long one, but hopefully you're gonna learn tons of things, and yes, let's get started. In the games section, you're gonna, once you launch the engine, you can go to the third-person template, and over there, what we're gonna do is to use the C++ version of it. We're going to target platform, and we're gonna go in the quality preset and say scalable, Scalable, sorry, we don't want that. That was my French accent taking over. Scalable, and we want that because we don't want the engine to be set up with advanced lighting and features. We want to be mainly understanding the engine, so no need to burn your GPU. Then we're gonna name the project. Let's call it Sociomix tutorial or intro. And you're gonna click create, okay? I highly recommend that you put your project on SSD at least, disk, and install the engine on the SSD because it's going to compile faster, and overall Unreal Engine is quite a powerful but quite big engine, so lots of files to parse and to load. So that's my quick advice, like try to get at least a SSD or of course NVMe, which is like probably the best gear you can have with Unreal Engine, and of course a decent graphic card in order to have some shaders, advanced shaders running, and like good rendering performances. But mainly when developing, the hard part for me at least is the compile time and things like that. So like I find it best when Unreal is running on an NVMe, especially also if you later on want to build your own version of the engine, which is possible, because as we will see, the engine is source free, source available, meaning that you will be able to open directly in your IDE the source files. And by the way, as you see the things compiling, the first time it's always going to be slow. And the next time you're going to open the project, it's going to be faster. You're going to see all the time that Unreal is giving you preparing shader, like compiling shaders, and like at least the first time it's going to be pretty time consuming. But once everything is set up, everything should be fine. So then you're going to have, because we've chosen to use a C++ project, by default Visual Studio solution that is going to open. As you can see, we have two projects in the solutions in Visual Studio. I highly recommend using Visual Studio 2022 at least, or a newer version of course. And personally I will be using an extension that is not cheap, I must admit, but a must-have if you want to develop professionally with Unreal Engine, and it's called Visual Assist. And Visual Assist is an extension that you can install. It will appear over there. You enable it, and basically it will be a sort of IntelliSense boosted in Visual Studio. So you will be able to have an extension that understands the code base of the engine, understands specifically Unreal Engine, and will give you function names and things like that, and giving you syntax highlighting that makes sense with the engine. And also, and we will see that later on, will understand some things that are not C++, but that are meant to annotate your C++ code in Unreal Engine, for your code for you to avoid doing some memory management, and also to expose some things, some variables, properties, and functions in the editor to make your code more integrated to the editor and available to the designers of your team or yourself if you're designing your own game. So Visual Assist is for me a must-have. You have a 30-day trial if you want to use it, but that's the only extension that actually exists that is robust enough to work with Unreal Engine. There is also another IDE that you may use that's called Rider, and apparently it's working quite great, but I have the habit of using those tools, so Visual Studio plus Visual Assist. As you can see in Visual Studio, you have two solutions. One is the game, actually, Okay, and the game is a module in the solution, and you have the engine over there. Okay, so we're not going to compile the engine, but you can reference all the files of the engine. So when you open it, as you can see, you have the source files, for instance, of the editor. So that's the source file of the editor. Sorry, you can see it's quite huge. You have some config files meant for different platforms in the engine, some shader code over there related to, of course, rendering, lots of things. And here, over there, in the game that we created by default, we have the source files over there that you can see, and we have some entry points, which is like, in this context, the CPP file, and over there, as you can see, and it's registering the module called Socialmake intro, and we have it's implementing it, sorry, and we have then some classes that are the default classes that came with the template that we're going to analyze together later on. This is the character, and then we have one class that's quite important called the game mode that we're going to analyze also later on. So that's for the, when you start at actually template, it opens Visual Studio, and you should see a different syntax highlighting if you don't have Visual Assist. Okay, but if you're following this video, it's probably because you want to become a professional Unreal developer. So I highly recommend using like professional tools, at least Rider or Visual Assist with Visual Studio. So when we come back in the engine, you can see we have multiple views, multiple windows. And by default in the engine, you shouldn't see exactly the same thing. So I'm going to show you how to find your way around in the engine in order to arrange it the way you want, arrange the layout the way you want. So by default, this shouldn't be docked. It should be like this, and you shouldn't have the output log. And if you press Ctrl Spacebar, you can see how you can have this window appearing, and this is new from this shortcut started in the 5.0 version, and you can here dock it in layout. So, and you will see that this window is called the content browser. The content browser, as its name suggests, is where you're going to find the content of your game, and also some part of the engine classes over there, as you can see. But if you don't see the engine part, it's also because if you right click on the content folder, you are not going to you're not showing the engine part. So sorry, it's right click and show. Where is it again? It's should be in the settings over there, and you have show engine content over there. If you don't have the engine content, sorry, like this, you won't see it because, yeah, you have to check this, okay? And you can also hide the C++ class, but we're going to mainly use some classes, so C++ classes, so it's better to have them there. So you can see over there that you have Socialmake's intro character with this icon, because it's a very important class in the engine. It's part of the what we call the game framework, and you're going to see how it works soon. And then we have another one with another icon that's also a famous class from the game framework, which is the game mode, and those classes reflects those .cppnh and .cppnh classes, as you can see. Okay, so the content browser, it's where, again, you're going to have your content. If you go, for instance, in the character folder of the template, you're going to see the mannequins. If you go there, you're going to have, like, for instance, the mesh, and you're going to see some meshes, so 3D model. When you have a 3D model that is bound to a skeleton or a rig or an armature, which is like a similar term, basically an object that can be deformed by bones, you're gonna see a small pink line that represent those types of assets, and usually we call them ASCII skm underscore plus the name of the asset, because of the naming convention skeletal, it means skeletal mesh. Okay, then we have sk underscore, which means skeleton. Okay, and a skeletal mesh is a mesh that is based on a skeleton. Okay, and a skeleton is just an amount, a hierarchy of bones. If we open, for instance, the default mannequin for from the engine, which is skm underscore mani, I double click, it's gonna open a new window. And it's gonna load what we call an editor. An editor is just another window where you're gonna have like different options for the object. It's a bit slow for whatever reason, but usually it's faster, and it popped in another monitor for me. So you can see that we have another window that we can dock it already here. If you don't like the window the floating window, you can go in the preferences, editor preferences, by going to edit editor preferences, and you can type you can go here directly in the general appearance and say asset editor open location. You can say it to main window, meaning that now if I close this window by middle click on it or closing it with the X, you can double click here and you can see that it already docks the object directly there, which is quite neat actually. So here you can see that we have the SKM mannequins, so called Mani, and this is just the asset. And as you can see in the asset details panel over there, it references the skeleton, which is called sk underscore mannequin. If I double click there, it opens it, and as you can see here in the skeleton tree, we have all the bones that I can pick and see for this asset. Okay, so if I press Ctrl A, you can see I'm selecting all the bones over there. Oh, apparently it doesn't show all the bones. I need to go to character bones and say whole hierarchy to show the bones. So you can see we have bones that when I rotate them, it moves the different parts of the object. So this is a basic mesh. We have shortcuts in order to switch between related objects for skeleton meshes, related assets, sorry, for skeletal mesh. So here, again, the pink icon is the skeletal mesh object. Okay, where we can also see the hierarchy. Then the difference is that this is the asset with the model, and skeleton can be shared among different assets also, and can be referenced for in what we call animation blueprints. That's where we're gonna deal with animation and blending animation together. Here we have, like, if we click there, an animation called mm_fall, which is like basically a timeline where you see the animation playing. And then here we have what we call the ABP_Mani, which is the animation blueprint, and this is where the logic for blending between animations is made. If we go in the anim graph, for instance, here we have the locomotion system, blending between the idle, the walk, and the run. We're not going to touch that for now, but maybe we are going to come later on in this view, but that's just for us exploring the assets that we have. So as you can see, we have pink assets, skeletal meshes, and blue assets, skeleton assets, so rigs basically, or not rigs, but hierarchy of bones. We have also materials, as you can see, that they are green and usually called M_, or sometimes MI for material instances, which are basically inherited materials from base materials. So you can also have a hierarchy system with materials in Unreal. And if we open by double-clicking a material asset, you can see it's a nodal view, a nodal graph, where you can basically set up you can write basically your shaders using nodes with using visual scripting basically. And you can see it's quite actually understandable the way it works, and we're gonna do our own materials soon, so don't worry about that. So that's for the sort of type of assets. If we go, for instance, in level prototyping, in meshes, you can see that now we have turquoise type of asset, SM, so those are meshes also, but that are statics. They are not meant to be changing with, like, animated with a skeleton. Okay, so if we open one, it's very easy, like in terms of the view. You just have a viewport with the asset, okay? And this is also where you can set up the collision. So here, for instance, we can show the simple collision, and you can see that they appear in green in the viewport, and they represent basically the shell where we cannot go through. We can also add, for instance, collision. So here I can add a sphere collision on top of that. And of course, if you press Ctrl Z, like in any software, you can undo that. But that's where you set up basically your objects. That's also where you can set up the material if you want of the object. So if I want to change the material type, I can do that here. So here you can see now it's a water material. Okay, so let's Ctrl Z that. And you have textures, of course, like that are in red, T underscore, usually they are named, and animations that when you open them, they are in green, darker green. If I double click an animation, you can see how when we relate the object to a source, we also have a skeleton over there that represents the animation will try to animate and move and rotate the bones that are in the skeleton. So you can see how everything like sort of makes sense in the relation of assets. You always have usually asset details over there panel that brings you some options and some links to reference other type of objects, assets, sorry. Then you have here the way also to look at other animations, but still being in this window. Sometimes the engine is going to reload some stuff, so you just have to wait, of course. So here you can preview other type of animations. Sometimes you can also, for instance, if we go back in the mannequin there and we go to the mesh and the skeletal mesh over there, we can also, for instance, here preview the animation. So we can say, okay, let me preview this animation. Apparently it's not working for whatever reason. Doesn't seem to work. So apparently let's open the skeleton directly, and here you can preview the different type of mesh. I don't know why it's not working, but it should. Oh yes, it's working over there. I just grabbed the same mesh actually. But basically you get the idea. You have a lot of interconnections between the different editors that you can open in the engine. Then it's very important to organize properly your folders, of course. You can also, if you want to have, like, for instance, a folder being colored, you can right click and say set a color, which is sometimes useful in order to find quickly the assets that you want. So that's one thing that's possible. Then that's for the content browser and what it contains. Actually, it contains assets in the engine. And if, by the way, you right click and you say open, you right click and you say show in Explorer, you will it will open automatically the Explorer where it is, and you will be able to see that you will have the same hierarchy over there. So you have the content folder like we have in the engine over there, and then inside you have level prototyping, the materials, and you can see how everything in Unreal is called .uasset. So uasset is a way to hide the type of assets from an external point of view, and that is understood by the editor and of course the engine. So when you're dealing, for instance, with source control, in order to work with a team, with Git or with Perforce, you better have to do that in the engine, and this is also possible to connect a source control in the engine. I'm not going to touch about that right now, but it's possible to connect to a source control over there using Git or Perforce, and Perforce being the preferred source control in large productions. So because it deals better with binary assets, which are in the end uassets. Okay. So just closing the thoughts regarding that. So again, you have uassets that in the end are understood as textures or meshes or sounds or different types of, like, the blueprints and things like that. Okay. When we say blueprints, and by the way, in the engine, blueprints are when our like classes, I will say, like C++ classes that represent that are using visual scripting concepts. So if we go, for instance, and look at animation blueprint, here you have logic, okay, that are written using bricks of code, bricks of functionality, sorry, and that are expressing logic, but not using code, basically. And if we look at it, for instance, in this context, I said I wanted to do that later on, but just to show you that it's quite easy to do, we can go there and say, for instance, okay, the first thing to do here is grab a reference to the movement component, then get the velocity of the character that is coming from the movement component. Then we set a variable that we can find over there. So if we look at there, we have a variable that is of type vector, and then we get the length of this vector. Okay, so basically grabbing the size of the vector, and then we set a variable called speed that is basically the length of the velocity, which makes sense, right, in basic math. And then we do a lot of logics like this. We can even like program a game or prototype entirely with Blueprint, but usually on big projects, in huge productions, we don't use blueprints too much because of performances, and of course it's not easy to maintain at a very large scale. So usually we use blueprints as shells, I will say, as shells, or as visual representations of classes with a minimum amount of logic inside the blueprint. So here it's a very specific type of blueprints because it's related to animation. So even in the engine it's a separated thing, but you can have more generic type of blueprints. If we look at, for instance, let's create a new blueprint later on, but basically here you can right click and say create a blueprint class, and if I derive it from a type that already exists in the engine, and we're gonna see the hierarchy of classes, you can see we have 672 items, so basic class in the engine that we can derive from, the most basic one being the top one being object, which is the base class for every sort of object in the engine. But if we derive, for instance, from a class called actor, which is something that can be placed inside of the world and visualized, therefore, if we derive this class, usually we call blueprints bp underscore, let's call it test. If I double click and open this asset, you will see that here we have on the top right, we have parent class, and it's from the class actor. I can even click there, and this is going to automatically open the actor class in Visual Studio that basically is in the engine solution. And as you can see, it's quite huge, and this is only the .h file. Okay, this is only the definition. It's huge also because everything is commented, so it's very easy to understand every piece of the code over there. Okay, but still, it's still huge because actor is a class that is very capable in the engine, and a lot of classes are deriving from actor, which are basically actor are the equivalent of game objects in other engine, if you want, or actually similar, or nodes in Godot, game objects in Unity, and basically those are like the way you can see the derivation in Blueprint. So if you open a Blueprint editor, you can see that you have a visual part with a viewport. You have a construction script, which is basically a graph of logic that will be executed at the start of the creation of the object, even in the editor, even when you're not running the game, playing the game. And you have the event graph over there where you can put some logic, okay, with different events. So in Blueprint, events are in red, and you can, if you're familiar with game development, you're gonna find some pretty familiar names over there. So begin play is the equivalent of start in other engines, such as Unity, for instance, or init for the actor. So basically, when this actor will be instantiated in the world, the begin play is where is going to fire, basically. And everything that is going to come out of this pin, this execution pin, is going to execute. So let's do our hello world with this actor. I'm gonna say type the print function in order to call it, and if I enter, you can see it connects to another node. I can, if I want to disconnect it, therefore removing the flow of execution, I can press the Alt key and click on the node. But now when event play is going to fire, nothing is going to execute. Okay, so if I reconnect back this node there, you can see that this node is a function because it's blue. And if you hover, you can see where it is coming from. It's coming from the Kismet system library. Okay, and here I can see that I can enter a string. So hello world. And if I open that, I have different options, like the amount of time I want to make it show in the game. So let's put 200 seconds. And that's it. And if I compile my blueprint and come back to the map, okay, and I play, nothing is going to happen because this object is not instantiated. Okay, so I need to escape. To do that, I stop there, and I need to drag and drop the actor in the viewport. So if I do that, and I grab with the gizmo, I move it up a little bit. This doesn't matter, but it's just I don't want to see it in the ground. You can see it has a visual representation that is an icon, but this in the end is not going to be visible in the game. If I play again, you're gonna see hello world here in the top left corner, and this is due to, of course, the BP, the begin play event being fired. And we can, if we undock the viewport there, and if we start again the game, you're gonna even say the execution logic going to go like with some bubbles following the path over there. And each time you have a function like this, you can see it has another pin that you can execute again. So for instance, here I can put a delay, okay, that is going to last for instance 2 seconds. And then I can select this node, Control C, Control V, reconnect that. And now this time I'm going to put it green, for instance, and say after 2 sec. Okay, and if I compile, come back to the map and play hello world, and after 2 seconds you can see we stack the rest. If I press Shift F1, I'm going to get back my mouse and I can stop the game, the execution of the game over there. Okay. So those are for blueprints. Of course, this is much more complex blueprints. You can really express tons of things with blueprints. For instance, I can say, I can add variables. So let's add, for instance, one variable over there. I can say this is a Boolean. Let's say door open, for instance. I can grab the variable, okay, and I can get the value of the variable. And let's say that I want to print before the delay. I want to print the value of the string of the value of the Boolean. I can say, for instance, here in the string, I can use a node called. So before doing that, I can right-click in the void here, and I can use a node called format string or format text. Which is basically like interpolating a string in C or C++ or in any language. I can push that as a string. You're gonna see it's gonna convert here using a convert node from a text to a string. So basically a text is a more advanced version of a string, taking into account localization for a game. So if you want to translate your game in Chinese or in English, etc., you can do that using the text macro. It's very advanced. And here in the format, what we can do is we can say hello world, the value of door open is, and then here if you put in parentheses like this or curly brackets like this, the name of a variable, let's say door, for instance, it creates a pin, okay, where you can plug the value and it will infer the type and it's going to show what is the value of the door. So before the execution, when we begin play, we print what? We print a string that is being converted. We print a string, okay, and this string is a text converted to a string where we say hello world, the value of the door open is, then with curly braces, the blueprint understand that it creates a new interpolated string like value, so it shows their door, and I can put another one if I want, like I can say whatever, and it creates a new pin, okay, I don't want to do that for now, and then I input the value of the door. So if I compile everything, go back there, you can see hello world, the value of the door open is false, which is the content of the value. But let's say that after 2 seconds here, we are willing to set the value, the door open to true. We can wire this by just drag and dropping the content of the value like this and using set. By the way, you can use the Alt key before you drag in order to access the set directly. And here we can check this box to make it true, to make the Boolean true. And if we print again by using the same logic there, the value, using the door open, you're going to see that it has been set before to true. And if I grab the value there like this, and we play, hello world, the value of the door is false, hello world, the value of door is true, okay, which is now working, okay, quite nice. And you can see here, if we follow a little bit with the blueprint idea, we have twice the same thing, which is usually not good in programming, and you know that. So we can definitely create some functions. Here, a function for just like formatting a text and printing it wouldn't be very valuable, but let's do it just for fun. I can select the nodes that I want, and I can right click and say collapse to a function. Okay, and now it creates a new function in the list of functions that I can say that I can call debug door open, for instance. And now I have this node that will be executing, and if I reuse here by drag and dropping the function, the debug door open, you will be able to see exactly the same logic, just I have been false, okay, and it's true. I have been just reusing the function, okay. By the way, if you double click in the function, you're gonna enter into the function definition, so I can go double click there or just double click on the node, and you're gonna see that this is the execution entry point of the function, like if in programming you were starting with curly braces, and this is the logic. You can even have input parameters. If you go there, you can plus, and this will add parameters. You can even choose, of course, the type, Boolean, bytes, float, whatever. We can, let's say, add a new one, which is a vector, okay, new param, and you can also have return. So if I drag a return node here, I can have return values, and I can have multiple return values, which is quite strange if you're a programmer. So you can see now that the function door open has multiple input now, multiple outputs, and it's the same thing like that, okay. So this is for blueprints, like a very quick introductions. In the event graph, you're gonna see that you have also other events such as collision detection, but you also have like the tick, which is basically tick is the update or the execute function from other engines. So if I print over there and say print, and I just do that, it's going to, of course, print forever in the console. Why? It's simple. It's because this function is executing 60 times per second. Okay, so this is just the frame event, okay, in the engine. So if you want to, for instance, rotate the actor or do a sine wave or something like that, you can use, of course, the tick. In order to do that, by default, you can see that if we go to the BP there, the actor is ticking by default if you go in the details over there. And you can say that, you can see that it starts with tick enable. If you remove that, let's go back to the previous example by Control Z. And if I remove that and I compile, you will see that the actor is not ticking anymore. And it's not ticking because because we said you start by not ticking. Okay. And if, let's say, I introduce more logic with, for instance, the spacebar. Okay, I grab a spacebar event. Okay, when the spacebar key is going to press, I'm going to say enable tick, and I'm going to check the boolean to say please enable the ticking of the actor. Let's remove that and say, instead of print, I'm say I'm ticking. You're going to see that. Okay, so maybe it's not a good idea to use the spacebar because it's bound to the jump and it grabs the input. But let's say the O key, or you know what, you can go and find the information that you want by going to input and let's say keyboard event, and here let's grab the C key for whatever reason. So let's go there and compile and press play, and apparently it's not working, and I know exactly what it is. You have to trust me on this one. The object is not enabled for now to receive inputs the way it's organized in this project. So instead of course, instead of like doing that, either we enable the inputs for this actor. So let's do that. Enable input. And we grab the controllers, just follow what I'm doing, it's not very important. Get the player controller, let's try to do that, it should work right now. And as you can see, it works because I enabled the controls on this actor. But again, this is not this was not the purpose to show you how to fix the issue, it's just the purpose to show you the logic of the tick. Okay, we're gonna come back on those ideas soon. So we've seen blueprints in terms of event graph, but now we're going to see blueprints in terms of composition. So when you compose an object, you can see that you have a hierarchy here with a parent, and it's inside this parent as childs that you can add some components that compose the object. So it works by composition, exactly like it would in Unity, for instance, or in a lot of engines actually. So here what I can do is I can start to add, for instance, a cube. So if I add a cube, you can see that I've added a brick icon there that is inheriting, this component is inheriting from a static mesh component. And if I over there, you can see where is the actual type of this component, what's the class. Okay, so you can see that it's going from types, static mesh, use static mesh. Okay, so it's a it's a static mesh component. Sorry, and you have details that are exposed for this object. So you can see if I change the type of object, I have different, of course, variable being exposed, properties being exposed for this object. But now, if I compile and come back to the viewport, you're going to see a cube appear because remember we've instantiated this actor on the start. Okay, so the cool thing now is that I can do, for instance, things with this actor. I can grab the cube, and in the tick I can make it rotate. Let's do that. So what I can do is I can grab the cube because it's a variable that is, it's a property of this blueprint that I can grab. I can grab this component as a variable, and I can, from there, I can say set rotation. And you're gonna see here set relative rotation, okay, and set world rotation, okay. And I don't know if we have offsets. Yes, we have world offsets, and if I don't know if I have rotation offsets. I don't think so. set local rotation. Okay, relative rotation. Okay, just world rotation will do the tricks for what we have to do. So if I do that, you can see that here I can wire things up like this. And what I can do is I can increase before setting the rotation a new variable that will represent the angle that we want to rotate around. So let's do that. I'm gonna grab a new put a new variable that I'm gonna call angle. It's going to be a type of float, of course, because I want a decimal number. And each time, so I'm gonna press the Alt key to set the value. Each time we tick, I want to increase the angle over there by the delta time, the delta second, so the time between the frame now and the last frame. So I'm gonna say plus, I'm gonna say angle, grab the current value of the angle, plus, it's gonna automatically filter it to the add function, the delta seconds. Usually I don't like to cross things over, so what I do is I tend to align when I can the lines, and then I'm gonna grab the result there and put it in the angle. So in the tick, I'm first going to increase the value of angle, and here I only want to change the z-axis, which is what we call the yaw. So the x-axis of the object, if you go in the viewport there, don't worry, I'm going to explain how to rotate around in the viewport soon. But in the object, the x-axis over there is what we usually call the roll. Okay, we have the pitch, okay, which is the green axis, the y-axis, and then we have the z, which is the yaw. Okay, those names are coming from the plane controllers, I think. And then I want to only set the z, so either I can go out there and make a rotator, which is a structure that corresponds to a rotation, and I can here feed only the z. This will work. If I compile and I start the game, you're gonna see you should see actually the cube working. If I press space, remember that the actor is not ticking, but C, sorry. Oh, I unbound the tick. So okay, let's make it tick again by default. Let's compile and come back. So you're gonna see, but it's going to very, very, very slowly, because why? Because we're talking in radians here and not in angle, in degree, if I'm not mistaken. But in any case, what I can do is I can multiply the delta seconds by let's say 20 to make it faster. And if we look at now, the cube is rotating faster. Okay, so this is quite great. But here we've made a rotator, but what I can do when I have like structs that are aligned like this, I can right click and I can split the struct in order to get access to the individual value of the struct. So here I can directly feed the value that I need to the yaw value, which is the z axis. And if I play, you can see we have exactly the same thing. Okay, so now we saw a little bit how the viewport is related to the graph. Okay, where in the viewport we can add different objects, we can have different components, and we can organize a blueprint with the composition of different objects. So we can have, for instance, a character that is going to be a skeletal mesh component. We can have an invisible collision box or sphere. We can have whatever component that we decide to develop ourselves, such as, for instance, an ability system component. We can have like basically a light. We can have like, I can even here, if I want, I can add a light, okay, in this blueprint. And if I put the light on top using this gizmo and I change the color, okay, And let's make it very intense, and let's change the radius of the light and make it there, and compile. If I come back to the view, you can see how this has replicated like in the different objects that are already there, okay, in the scene. And the cool thing is that if I add multiple actors there in the scene and I change one thing, such as the color of the light, I recompile, I come back, all the lights have been changing, okay. And of course, if I want to specialize one actor in the scene that is there already, what I can do is I can go there in the scene and I can override a value. So let's say that I want to change the cube for a sphere. I can grab the cube in the hierarchy there in the details panel. If you don't have the details panel, you can go in window and find it's in not content browser, not viewport. Where is it? Where is it? Not outliner, it should be somewhere over there. Okay, so I've just closed the windows, apparently it's there. I was mistaken, so I also by mistake closed the world settings. Okay, so let's come back to the detail. So you can see here that I can grab the cube and get details that I can override. So now I'm going to take over the default value in the blueprint, but it's specific to this thing. Okay, but still, if I go there and change back the light to something pink and compile, come back, even this version of the actor has a pink light, as you can see. Okay, great. So we've talked about actors that are objects that can be placed in the world. Okay, so let's remove those actors like this, and now before going further, I think it's a good idea if we look at how to move in the viewport, because that's something that you're going to do a lot. Okay, so if you want to move in the viewport, you can right click in order to orbit around. Okay, that's a simple thing to do first. While orbiting, if you add the left click, you're gonna have a sort of up, down, left, right panning motion. That's possible. If you remove the left click, you're gonna be back in orbiting mode. Okay. If you want, while clicking right click, you can press WASD in order to move around in the viewport. If you are using a French keyboard or not a QWERTY keyboard, what you can do is go in the preferences and you can start to type move. And here you're gonna filter, and at some point you're gonna find, or maybe not move, actually it's forward, sorry. If you type forward, here you're gonna see viewport navigation, forward. I've changed it to Z because I'm not using a QWERTY keyboard, but you can now filter by viewport navigation, and now you have all the keys that you can set up. So I've basically changed them to the ZQSD, which is the French equivalent to QWERTY, and also up and down. Up for me is the E key, and down is the A key. So on a QWERTY keyboard, it will be the Q key and the E key also. So right click, WASD in order to move, A to go down, E to go up, and that's a very fast way to navigate around. If the speed is too slow, you can scroll the wheel up while navigating in order to go faster, and you can scroll the wheel down in order to decrease the scale of the speed, or you can go in the top right corner there and change the camera speed over there, which is possible. Okay, so if I go with a 1 speed, you can see how slow and turtle I am, and if I go to 4, which is the default, I'm faster and it's a more accessible way of navigating. If you want to pan, you can middle mouse in order to pan, and usually what I do is, personally, I like to go in the setting, in the preferences, and I like to invert the middle mouse pan to make it work like in any other 3D software, such as Blender or 3ds Max or Unity, which basically do a pan that if you take an object, it's like if you're moving the object in the same direction. Okay, so I prefer to invert the middle mouse panning motion. Then that's for the navigation in the viewport. If you want, you can also press F to focus on top of an object, and if you press Alt and left click, you're gonna orbit around the focus of the object. So let's say I have a cube there. If I right click, I orbit from my position, so it's like if I were looking from my point of view, and if I press F to focus around this object and scroll wheel to zoom out a little bit, if I press the Alt key and left click, you can see how I'm rotating around the object. Now I remove the Alt, I right click to orbit around myself, Alt and left click to orbit around the object. If I want to move an object, I can use the gizmo, the arrows, to make it move in the direction that I want. And I can also use the planes in order to move it on both axes of the plane. And if I grab the small sphere in the middle, I'm going to move it on all the axes, and I should move it on all the axes at the same time from my point of view. Okay. If I want to switch to a rotation gizmo, I can press the E key, okay, which will enable the rotation, and R will enable the scaling. So you grab the small handles to scale the object. If you press the spacebar, you can also cycle through the different gizmos, and you have them there here. If you press the Q key, you're back to selection mode where you don't have any gizmo. So the 4 keys that you have there are also written: Q, W, E, and R. Okay. If you want to change to local mode, you can use the wall to object there button to cycle through. The cool thing is that you can bind a shortcut for that. Again, if you're using a French keyboard, you have to bind it because it's not bound by default. So it's I don't recall the name of the cycle object space. Let's type object space or world local space. Local. Let's go in the shortcuts, actually, keyboard shortcuts over there, and let's filter by world. Should be control and apostrophe. Okay, let's say local. Control or object. Where is the binding of this cycle? Yeah, it's cycle transform coordinate system. So just here replace it by control and the 4 key on top of A0 if you are using a French keyboard. And as you will see, it's faster for me to cycle through world and local. So world basically is aligned with the world, the gizmo that you can see on the bottom left corner, and local is taking into account the rotation of the object. Okay. There is something I'd like to bind also in the preferences is screen rotation, like this, which enables you to, when you are using the gizmo, having a circle that enables you to rotate from your point of view, which is super handy when you have to do quick rotation. So if I want to do a very quick realignment, not precise but very quick, I can do it like this. You can also see that you have buttons over there to snap the objects, to use the grid. So here you can see how it feels snappy. If I increase it, it's going to be even snappier. And if I uncheck this button, I'm going to be like smooth in terms of like not snapping to the grid. Same thing for the rotation here. If I rotate 30 degrees, not using the screen's rotation, which is weird by the way, but using the axis, you can see how it snaps 30 degrees by 30 degrees. And if you remove the snapping, it's smoother, and same thing for the scale over there. Okay. If you want to put the transform back to 0, you can go in the details panel over there, and you have transform section, and you can click on those arrows to reset back all the values. And if I press F, you can see that my cube is not placed anymore to the where it was, but to the center of the wall, 0, 0, 0 in world space position. If I want, I can also press the Shift key while moving an object to bring the camera with the object. This is quite great because when you have a large open world, sometimes you want to do that. And if you want, you can also use the end key near the delete key on your in between your main keys and the numpad, and this will drop the object on the ground. So if I do that there, you can see how it drops the object on the closest surface. What else can I say with those with the viewports? You can press the control and middle mouse button in order to switch between different views. Here you can see how I switch to the back view, and now here I have to right click in order to pan around. Okay, so control, and you just do a gesture using the middle mouse button as a click. Okay, so I click the middle mouse button, I go up to go to the top view, I go in the lower corner to go back in perspective, I go, of course, right to go, left to go back, right to go front, up to go top, and bottom to go down. And if you are losing it, you can go here in the top, and you can also use the shortcuts that are there, or of course you can use the view that you want. You can also right click on this button in order to have a quad view, which can be quite interesting in some cases, and you can maximize one of the view again back like this. You have different ways of visualizing the viewport without lighting, in wireframe, with detail lighting and things like that, but usually you stay in default lit. And if you want, you can also duplicate an object using the move gizmo by pressing the Alt key and grabbing an arrow. As you can see, this duplicates the object. You can press also Control W Control D to duplicate, or Control C, Control V works also. On the left side here, by default, you have the outliner. If you've closed it by mistake, you can go Windows Outliner, Outliner 1. And those are the objects that are present in this map, which is, the map is a level, basically. You can see we have all the cubes that are static meshes that we can find there. By the way, if you want to see the assets, the related assets, you can always analyze the details. And you can see here in static meshes that we have this object. And if we click on this button, it will search for us, like point directly in the content browser that is open, the asset that is related. Okay, so that's a neat shortcut. Okay, so now I think we have enough knowledge to pursue our exploration, but more on the dev side. So we are going to first analyze the project in terms of, like, we're just gonna play the template and see how it works and how we played the game, and we're gonna deconstruct it in detail, and then we're gonna add a feature on top of that in the template, just to show you how it's possible to work with the engine. Okay, so let's get started. So we understood that with the small exploration of blueprints, that everything can be derived from classes that the engine has, and as you can see in the game, we have like a small map being built with the basic static meshes. I recognize them because it's written SM_, and you have also the brick icon. We have some lights, so if we go there, we have a directional light that when I move it, you can see how it changes the lighting and things like that. So let's play this level. Okay, I'm gonna click the play button there, click in the viewport, and as you can see, first thing is I can rotate around, okay, which is already something that is logically working and that we need to understand how it works, right? We can also press WASD, jump. You can see how the character reacts. We can see how we have some nice animation. We even have eye keys, foot placement that's working. We may not for now understand how it's worked, maybe not in this tutorial, but you can see we have collisions. We are blocked by things. When we press space, we jump, and that's all cool and dandy, and this is like basic what we like to call three C's in the industry, we can see that we can not move this cube, okay? And that's it basically. And if I press Shift F1, I can go out of this and stop the thing. First thing I want to show you is that we can bind new inputs, and this is going to be the first thing that we should do if we have French keyboards in a template. So let's do that first. So if I go in the template, you're gonna see we have lots of things. Okay, we have third person here, and inside third person we have inputs, and here we have IMC, which is input mapping context. It's an asset. Okay, it's yellow. Usually everything related to inputs in new version of Unreal is yellow. This is where it's going to be different from Unreal 4, by the way, but just to show you it's there, input mapping context. If I double click there, you can see that I have a new window with mapping information, and I can see I have some keys that are bounded there. I have the spacebar, the gamepad, and the touch control as an input. And then I have WASD up, down, left, so I can even play with the arrows. So let's change the WASD by ZS, Q, and D for the French keyboard. Okay, and if I open there, you can see exactly what it corresponds to. Okay, and we're gonna see how it works in the code. And for the look around, you can see that we're using the X, Y mouse, meaning that when we move the mouse on the x-axis of the screen and the y-axis of the screen, this is going to return us a vector, okay, corresponding to those information, or it's using the stick of the controller. So if we come back now in the map and I play it, I should be at home, being able to control this thing properly. Okay, I cannot press escape, and we're gonna fix that later on, I'm sure. So press Shift F1 and stop the game. Okay, so that's for the inputs, at least the assets of the inputs. If we look at the assets, by the way, we have this as a sort of a general structure storing the inputs, and as you can see, we have the inputs individually represented as input actions. Okay, and if we come back to the content browser, by the way, you can always press Control Space to have a quick content browser over there. So let's come back to third person inputs and actions. You can see here that we have the jump, the look, and the move input action, IA underscore, and not AI. And you can see that an input action inherits, by the way, from an asset type called input action. I can always click and look at the engine how it works. You can see input action definition. That's our instance per player. Okay, and you can see like all the informations. Okay, this is the engine code. So let's remove it for now. But you can see that, for instance, the move action represents an action that can be consumed, of course, and meaning that can be used and consumed, and we can go to the next input. And the value type is of type axis 2D. Therefore, it's going to be a vector 2D type. Okay, it's quite important because then in the C++ side, we're going to use this input and we're going to receive an axis. Okay, so a vector with two components, x and y, and those x and y, if we come back to the main input section, we can see how we are using here the information, and we're mapping here the information. So if we open this and we do that, we can see how in the modifiers over there we are using here the input axis values, okay, in order to get the values for the z-axis. And here we are again using the input axis values, and we're negating the result of this action because it's the opposite key. Okay, so this is a sort of modifier, okay, that will remove, like, negate the action. Okay, and if we open the D key I want, and if we open the other things over there, you can see that we are not swizzling, but we are still negating the Q key. And we can understand by this mapping that Swizzling here is probably a modifier, okay, and this modifier is giving back, swapping, as you can see, the axis. So here we are swizzling in the sense that, I know it's a bit complex, but we are swizzling, meaning changing the order of the vector, okay, by making the y the first component, okay. So overall, when I press the Z key or the W key for a QWERTY keyboard, this is going to give me back the y, so the first component, because we don't care about the two other ones. It's going to give me back the y value of this axis, which is going to be 1, because it's a binary key. I just press Z, I go forward, okay, it gives me 1. In the context of a stick here, you can see that we don't have those things because the stick is already a 2D axis. Okay, it's between -1 and 1 on both axes. So it's already returning a granular value, if you want, a float value. Here it's like going to give me directly 1, return 1. And if we look at the other one, we are still swizzling because we want to get back the y-axis. Again, we don't care about the z and the x, but we're negating the thing, okay? It could have worked also with the other swizzling like this, just to prove it to you, because we don't care about the other axis. So if I play the map, apparently it's not working. Oh, that's right. That's sort of weird. So I'm gonna put it back to the other one, which was xz, like this. It's swapping the x and the y-axis, useful for binding the y. Yes, okay, it's swapping the x and the y. So I need to swap the x and the y. That's why it's important. Makes sense. So now if sorry, and it works. Okay, Shift F1 and I stop. So that's a bit weird, but that's the way it works, and we're gonna see how we're using that in now the character. But first, before looking at the inputs in the code side, we need to understand how the character is made. First, why the character is spawning. The character is spawning at this location, okay, which is a special object called a player start, and you can see that the type is of type player start, okay, and a player start is a class. If we press Control, if we right click, we cannot see it there, but if I derive a class from player start, you can see that it's a class that exists over there. Let me do that, and if I double click the actor and look at the player start class, you can see it's a player start class of the engine. Okay, so it's basically an object that represents where the player starts. Makes sense, right? Let me delete this blueprint. So if I move it there and I play, it starts there, okay? But that's not all, because I can also, if I want, right click here, for instance, and say play from here, and I can totally override the fact that I've played with the player start. One thing is important in a Unreal game is that we have lots of classes that are considered as gameplay classes that are made for very common things that you will find in any game, such as a character, such as an actor, of course, we mentioned that, but those actors are not specialized. You see what I mean? Those are just objects. Those are basic, very basic stuff, not a lot of functionalities. A character has a lot of functionality. You can jump, you can fly, you can move, you can collide, you can slide, you can do a lot of things, basically. So Unreal is already providing you with very expert and very advanced classes, basically made by the best programmers in the game industry, probably. So you better be smart and use and understand how it's made to derive from that your own behavior, or to at least use them the way they work by default. So character is one of this class, but you also have one class that is in between, I would say, common thing and not, but it's called the game mode. And the game mode, you can see that because of this template, we already have one being created there. and this is referencing directly the C++ class. So if we look and browse to the asset, it should actually point to the to the class, but apparently it's not. So let's look at it. It's there. It's this game mode class. Okay. A game mode, if we open it, has basic functionalities. Okay, and those basic functionalities are the properties. Sorry, not functionalities, but also functionalities, but basic properties that are usually common for a lot of games. So we have what we like to call the default pawn class, which is what object are you going to control by default, and a pawn in the Unreal lingo is an object, is an actor actually, that is a bit more that has a bit more functionalities that you can possess, and you can possess it using a controller. Okay, and if you want to imagine to have a good idea of how it works, you have the pawn that is the actual shell, the actual thing existing in the wall that is brainless, that has no brain, and that is there waiting for somebody to put a brain to move it or to do something with it. The controller is sort of the brain, and the controller is also an actor, but it's an invisible actor being instantiated in the game that actually will take control and possess an object. Okay, imagine that the pawn is a sort of a zombie character that has some functionality but has no brain, and the controller is the brain. By the way, if we start the game like this, you can see that we have here the pawn character that has pawn, but it's through a blueprint. Okay, and that's the blueprint that we're going to open in order to disconstruct it. Wow, that was hard to say. And we also have, as you can see here, a player controller that has pawn. Okay, and this is of type player controller. So that's the brain, that's the object that's going to be controlled. So when the game mode, which is sort of the entry class, if you want, for your game, it's the main manager of the game, if you want. It's where you're defining the base properties of your game, and that's usually where also you define the rules of your game. Basically, the game mode here, the Social Mix Intro game mode, is where we define, okay, we're going to use the third person character as the default pawn class. Okay, and also, as you can see, we are using a standard player controller class that this is not a class that we wrote or that the template is bringing to you. This is the default Unreal player controller, and this player controller is the default player controller that is going to possess the pawn class. Okay, and then we have other classes. Some are not used. Usually HUD are not used anymore, but you have the game state class, player state class. Those are more related to a multiplayer game. And the spectator class is also legacy. It's usually if you want to spectate the game, like in a first-person shooter match. You must understand something that's quite important. Unreal was a FPS engine. It was made for doing Unreal tournament. So you have lots of terms that are coming from this idea of having a mode that is like a deathmatch or capture the flag or things like that, that can be used in the game mode, but you can also define your own way, your own modes that are not in the lingo of FPS, of shooters, but still you have a huge legacy of this in the engine. Okay. So as you can see, we also spawn a player state by default. That's more for the replication in the online side. We're not going to talk about that, but you can see we also spawn a HUD that's defined there. But how it's defined? It's defined through the code. So let's open Visual Studio and let's open the game mode. So in the game mode here, in the .h file, we don't have a lot of things. If we press Alt-O in order to switch to the CPP file, Alt-O, by the way, is a shortcut from Visual Assist. Otherwise, it's Control-K, Control-O, if I guess right. Yes, Control-K, Control-O in the Visual Studio Vanilla. But you can see here in the constructor, so that's the entry function of this class. When the class is created, the constructor, of course, is being executed. You can see that we basically, and this is very bad practice, that's the template, and the first thing we see is a bad practice, but we're gonna fix that just after. But the first thing we see is that we are going to grab the path of the character, that is a blueprint, BP underscore third person character. We're grabbing the path, it's in the blueprints folder, in the third person folder, that is in the game folder. So game folder is the analogy for the content folder. So okay, I don't know why it's written like this, but game is content. Okay, then you go in third person blueprints and you have finally BP third person character. Let's come back to the code. You can see that we are using an object that is quite weird called class finder. That is a template of a pawn. So we are in the end, of course, storing in an object called player pawn BP class. We're storing a reference for the class to be spawned. Okay, so that's not an object, that's the class. And that's where the C++ thing of Unreal is very different. We have this notion of what's the class type, okay, and what's the object, okay. So player pawn BP class, you must imagine that that's just a variable that knows the class of the object to be spawned, okay. So when the engine starts and do its thing, when it sees the game mode, it says, okay, please instantiate at the player start a pawn that is of this class. Okay, so I know it's a bit weird, but that's how the engine works. And usually you don't look at this code because, as I mentioned, it's quite bad. Usually what we do is we derive a blueprint from the game mode. Okay, so we have the C++ version that's our own. Okay, I'm going to remove everything that's in the constructor because it's bad practice again, and I'm going to recompile. So in order to recompile, the first thing you need to make sure is that in the editor here you don't have live coding. That's bad, that's evil. You don't want live coding. Okay, now you come back in the engine, in the Visual Studio, and you press Ctrl B. Make sure you're pressing Ctrl B in order to rebuild the thing. It's rebuilding. Okay, it's crashing because sometimes it will crash. If it crashes, usually you have to restart the editor from the source code. To do that, it's Ctrl F5. But I must say that the engine is usually quite stable, but sometimes it's better to restart the editor, sorry. So if you press Ctrl F5, you're gonna, from the solution, restart the engine. And as you can see, the target is development editor. So those are all the things that we've changed and that were saved. Okay, we don't care about. Let's skip the restore. It's not very important for us. We're back to the game. And if we come back to the world settings, in the game mode, that is going to be the game mode used. Now, if I open the thing, you can see that we don't have anymore the BP reference there. So what do we have when we start? We don't have our character. We don't have, again, the inputs being changed, but we have the default pawn of the engine that we can see actually. If we press F8, we can eject from we can eject the controller from the pawn, meaning we can unpossess. And if I move around, you can see that the default pawn is a sort of sphere that you can control with WASD. Again, this is legacy. You have to have a pawn that spawns in an Unreal game. Okay, and if you don't, it's going to use the default one of the engine. But we want to override that, of course. So to override that, what we're going to do is we're going to create a new folder in the content folder, going to call that game modes, enter in the folder. Let's create a new blueprint class, but this time we're going to open all the classes and we're going to grab our own class called Sociamix intro game mode that was generated for us because we started with a template, but we could have created a new class from scratch. And I'm going to select it, and I'm going to call this blueprint BP underscore Sociamix game mode, and I'm going to drag this game mode instead of the game mode C++ class. So now we have a sort of interface between, not as a proper interface in terms of code, but we have a sort of interface between the C++ class and the editor, which is the blueprint. Okay, so I can drag and drop it there. And now you can see that if I double click the blueprint, again, I have something that you may know that is like a sort of a basic viewport with like an event graph and things like that. But here also I have the default class in the class default options there that are the properties of this class that I can set up. Okay, if I click on the parent class, you can see that I'm back to my class, my own class that derives from a game mode base, which is the base class, the base game mode of Unreal. If I press Control click, by the way, there, I'm going to enter into the class of the engine, and you can see that here we have the basic game state class, the player state class, the default pawn class that are there and available for me to edit. Okay, I can see that because on top there is a macro. Okay, and this macro is part of Unreal. Okay, it's not pure C++. It's a macro that is going to define what's below in terms of accessibility in the editor and in the engine. Here you can see that I can change the default pawn class anywhere. I can edit it from anywhere. So in the engine, it means that I can go there and can change the default pawn. Sorry, I can change it there, but also I can change it in the level here directly. I can change it basically anywhere because I have full access. I can read it and write it. Therefore, I can change this variable in the blueprint, and it's in the category called classes, as you can see. Okay. Of course, thanks to inheritance, I also have those properties in my Ace Sociomix intro game mode class. And if I come back to the engine, here I can change the default value in my game mode. Okay, so let's do that. I can even do it in the begin play if I want. I can say set default, default. Okay, let's right click default pawn class like this. I wire it like this, and I select the class which is BP, which is Sociomix intro character, like this. Yes, it's Sociomix intro. Oh, it was something else, right? I don't know, but if I compile, I should be able to... this doesn't work because maybe it needs to be set up before the begin play. So, wrong example. Usually I don't do that. It was just some improvisation that didn't work, but usually you change it there. So, and here you should... That's strange that I don't have access to the BP. Oh, it's called tutorial character. Okay, I think it's this one. Let's look at it. No, it's not this one. That's where I had... It's in third person, it's in blueprint, it's BP third person character. Okay, it should be this one. Okay, I can do that. I can bypass that by just if I have the object selected in the blueprint and I click on this arrow, I will set the actor that is actually available here or selected in the content browser. But this works, as you can see, but this bothers me a little bit that we don't see the actual object. So let me try to find why. Maybe in the settings there I need to show internal... Oh no, sorry, I'm quite blind. It's there since the beginning. Okay, so it's there. Just because I'm curious, and you should be, I'm gonna try to again set the default tone and see if I have the BP third character there. Yeah, no, it's not working. I think begin play happens after the engine is setting up all the classes, which makes quite sense. So let's come back to the class default and let's set over there, instead of none, let's say BP third person character. Okay? So that's great. Now we have a class that is a sort of interface between our C++ and BP, so I can start here to write some logic and say hello from Blueprint, for instance. And if I want, so hello from Blueprint, it works in this general class that is the sort of game manager, if you want. And if I want, I can go in the C++ side of things, and I can say, for instance, in the constructor over there, I can write a macro that is called UE underscore log, and I can print to this time what we call the output log, and not directly to the screen. I'm going to show you how to print to the screen right after. But here I must say what's the category I want to write in. And by the way, if you're using Visual Assist, I highly recommend you to write some snippets of code. So I'm just going to show you that. You can go in Visual Assist, Tools, and you can go in Edit, Snippets. And here I've created some snippets of code such as UE underscore log. And as you can see, I have some shortcuts that writes directly the line for me. And here this sort of tag will put the caret where I want. So you can see how this is much faster for logging, but because the log are long in Unreal, but I can say log temp, which is the category. Then, as you can see, the verbosity. So is it an error, a warning? Is it something normal? So I'm going to say warning. And then you have the format, which is you should use a text macro, and inside you can write whatever you want. So I can say hello from C++, and that's it. And I put a semicolon or not because it's a macro, so I don't care. If you press Control and click on the text macro, you're going to see where it's defined. It's defined there, if I'm not wrong, and this is a macro that's quite complex, but it's for taking into account lots of platform specificities and lots of different characters and things like that. So that's it. If I save and then compile, Control B this time, it shouldn't crash this time. I come back, I open the output log. If you don't have it, you can see that you can go here in output log over there, and you can see that already, because this is the game mode constructor, meaning the game mode will be instantiated by default even in the editor, it says hello from CPP. And if I clear the log and I play again, you should see the log coming back, because when I start a game session, the game instantiated everything and the game mode is back there. So I have hello from CPP also. Let's say that I wanted to now do that not in the constructor, but in the begin play. So I can come there, and now here I can override some functionality of the game mode. So I can press Alt-Shift-Q, which is the shortcut for Visual Assist, but apparently Visual Assist is not happy with me, so it doesn't want to show me the... doesn't want... I cannot... that's quite strange. Let me... because Visual Assist is quite a good friend in this sort of situation. So let's remove the extension and let's enable it back. Usually it takes a little bit of time for Visual Assist to parse everything. But once you have it, it should work, which is quite strange. And in any case, we can control click there and we can override some functionalities. So you can see you have a lot of virtual functions, and the one we want to override is begin play, or in this context it's called start play. Okay, transition to calls begin play on actors. Okay, I don't think we have the init. We have post login and lots of things that are functions that we can override to hook when the game mode starts actually, but let's override start play in our context. And I'm quite sad actually that Visual Assist is not working in this context. You see we have we have with Visual Assist, we have the override virtual function usually that works. Okay, so I restarted the Visual Studio solution and apparently now it works. So I can press Alt, Shift and Q, which is the magic shortcut for Visual Assist. Shift, Alt, Q, as you can see, and I can implement virtual methods. And this is super handful because you can see a lot of the methods and you can override them very quickly. So here, if you type Begin Play, you will be actually seeing Begin Play, which is something great because a game mode is an actor. Okay, so it inherits from actor, and you also have Start Play, which is another function from the game mode. Okay, once the game mode has starting to play, I think it's quite descriptive. So let's implement Start Play. Override at least Start Play. It takes a little bit of time, at least the first time. And now what I want to do is I want to put a log inside there. So one thing that's super important when you override function from the engine is to call the super function, meaning that you're going to call the base function. Okay. If I go and double click and left on super, you can see how it points directly to game mode base. So it's a sort of token or a sort of a keyword that points directly to the class behind the scenes. So I could have made a game mode base directly. Something like that would work the same way. Okay. So here I'm gonna add a log. So I have my macro in Visual Assist. You can feel free to type it, but I don't want to lose time with this tutorial. And here I can say Start Play. I can Control B to build the solution, and we should see Start Play actually arriving, and you can see Start Play as a warning. Okay, now let's and you can see that if I clear the log and I just rebuild, you can also use this compile button. You can also see that you will have hello from CPP from the constructor, but of course Start Play implies that you started the game. Okay. You can also control click on Start Play to learn more about this functionality. And if I press Alt G, I can, using Visual Assist, I can go back between the H file directly on the function, and it says transitions to calls Begin Play on actors. Okay, so it's quite simple to understand that we're a hook for us to start having initial information in the game mode. So here what we can do, initial logic in the game mode. So here what we can do is now, instead of like logging directly to the console, the output logs, what I want to do is to add a message on the screen, and there is, I created the macro again for that called, I called it DM. I just typed DM and you can see it propose it to me. And basically this is this line of code. I'm using a global variable called gengine, a global pointer called gengine, and then there is a function called add on-screen debug message with some parameters. The first parameter is the key. So a key, you can imagine, it's a sort of categorization of the logs. Then the time to display it, the color. You can see that I'm using a struct with like pre-made colors. You have tons of colors by default. So if I control click, you can see you have green, blue, yellow, whatever you want. And then you have a string. Okay, so a string here, you can see we're not using the string from the standard template library. We're using the string from Unreal, which is annotated with a F in front. Okay, F in Unreal, when you have an object that starts with an F, it means that it's a struct. Okay, so if we go there, you can see that it will be called F string, but that's strange because usually F starts for R classes. So I'm quite surprised that it's actually a class, but usually it's a struct. And when you have a A in front of the class, it means that it's an actor. Okay, and that's for sure. So here I have a string, and inside the string construction, I can type whatever I want. So hello, the game has started. I can build that, and I can start the game, start to play, and I can see hello, the game has started. And this is coming from the, I will say, the game manager, the main class of the game, okay, where you define the rules of your game, the entry point of your gameplay logic, I will say, where you instantiate the character, etc. Okay. Just to warn you, usually you should check if the pointer is ready, because when it crashes, if the pointer is null, you're gonna have a crash, basically, because it's C++. You're gonna have a access violation error. And also, one thing that's nice is that be it in UE logs or not, you can also interpolate values. So I can say, hello, we are on, and here I can put %s, and just after the text I can put the value I want to interpolate. So let's say I want to put a string, so I'm constructing a new string, sociamix, and here I can put %d to send a new value. So you can see how this is going to replace the %s there, and this is going to be replaced by the next one, etc., etc., to infinity. So if I press Ctrl B, you're going to see how apparently this is not working. And oh yes, I forgot something very important, is that this accepts C type string, so you have to dereference the string by using a star in front. So I know it's weird, but the overload of this operator actually returns the pointer to the first element of the string, which basically returns a C type string. So I know it's a bit weird, but remember just that when you're logging a string using UE log, you just have to dereference it. Okay. And hello, the game has started, and in the output, hello, we are on Sociamix and 42. Okay. So just put a star. If you're not coming from the C++ world, just put a star in front of the pointer and you're good to go. Okay. Same thing we can do here. Instead of checking the pointer like this, I will return if the pointer is null, so it's going to be easier for me. And here what I can do is I can also, and I have prepared another snippets of Visual Assist with parameters. So you can see that here now I can use a printf function from the fstring class. This is a static function, and then inside, if I put a text macro with the text that I want, I can say hello from %s, and after the printf as arguments, I can put my arguments. And so here I'm going to put once again hello from, instead of Sociamix, I'm going to put Earth, and if I compile, Ctrl B, and I come back to the engine, should work. You're gonna see hello from Earth. Great. So we know how to log, and we know that we have a game mode. Okay, so the game mode again is the thing that is actually spawning the character, and also so the pawn, which is the sort of shell that is stupid without any brain, and it also spawns the player controller that possess a pawn. Okay. If we go in the BB third person character now, and we open the full blueprint editor there, because sometimes it doesn't open for whatever reason, we can see in the viewport how it is constructed. We can see that we have the root of the hierarchy, then we have a capsule component, and you can see that there is a edit in C++. We can see that it is from the character class, because our object inherits from Sociamix intro character that in the end inherits from a character. The A means that, again, it's an actor, and a character means that in this a character class, we're going to have all these properties and methods that we can use, and the capsule component is by default in the parent class of our character, our Sociamix intro character. And you can see that we can look at the source code, of course, there. We have the arrow component that's just an indication for us in the editor. It's a debug tool for us to know where the character is pointing at. Then we have a mesh, and all of that we cannot remove them. It's written in C++, so if we need to remove that, we need to reduplicate the character class from the engine, having our own, remove it, and then inherit from this instead. But that's bad practice. Of course, you should keep, you should follow the structure. If you need to remove something, it's probably because you don't need a character, but you need to rewrite, you need to use another class, such as pawn, for instance, which has less enforceable component. Then we have a camera boom, which is basically a selfie stick, okay? A super selfie stick in the sense that it's blocking the walls. So if we have a wall in between, it's going to shorten its length. And if we have the camera that is a child of the boom, it's always going to be attached to the end of the stick. And therefore we are going to have, if we play super good motion, when the stick collides with the ground, you can see how it shortens, and therefore we don't go through walls. Here, for instance, you can see I will be moving. The stick between my character and my camera is colliding, intersecting a wall. Therefore, therefore the stick is shrinking, and therefore the camera is moving because it's at the end of the stick. Okay, so that's the camera boom. It's not called a boom actually in the engine. It's called spring arm component. I don't know why in the template they call that camera boom, but you have a lot of also neat functionality with the spring arm by default that we're gonna probably look at when we're gonna dig and put some question on the table, because the idea is that we are putting some questions like how this camera rotates. Okay, we know that the camera is attached to a stick, so probably it's the stick that is rotating, but how the stick is rotating, and etc. etc. So those are all the questions that we're going to ask ourselves and discover how it's made in the engine, but one thing at a time. So we also have a character movement component. That's not a component that is visible in the scene. It's a component that, as you can see, is inheriting from uPawn movement component, okay, in the description. And if we edit it in C++, we're gonna see it there, character movement, and it's a pointer. So in Unreal you have class objects that wraps pointers of type T object pointers, and they give you like more functionalities than raw C++ pointer, but you just need to think about them like pointers, like object pointers. It's just behind the scenes in terms of memory management. There are some stuff done automatically for you. So imagine that you're manipulating a raw pointer with that. So here you have uCharacter movement component. If I click there, you can see that inside it's inheriting from uPawn movement component, and if I click there, it's inheriting from uNav movement component, and if I click there, it's uMovement component, and if I click there, it's a uActor component. And a uActor component inherits then from uObject, which is the highest parent in the hierarchy. So we stop there, and we understand that a uActor component is the base class for components that defines reusable behavior that can be added to different types of actors. Okay, so that's great. But that's, as you can see, we've been inheriting from uActor component, but not from uScene component. And there are some other objects such as, for instance, the mesh component. If we edit it and we go there, we can see that. So the mesh, here you can see it's a uSkeletal mesh component, but this inherits from uMesh component, which in the end inherits from uPrimitive component, which inherits from Scene component and not Actor component. And a Scene component is something that can be visible in the game. Okay, so it has a transform actually. It can be moved, it can be rotated, scaled, and things like that. So that's why when we select the character movement, we cannot move it. Okay, it's not something that is physical. And the mesh, because it's a scene component, we can move it, we can rotate it, scale it, and see it also. Okay, so basically, actor components are components that are made for doing some logic stuff, okay, and helpers for you to do some logic. And scene components are there for visible stuff, plus logic, of course, if you want, as we are gonna see later on. Okay, so that's the character. It's the BP character that we created. Okay, let's come back to the class that corresponds to our character. I'm gonna close everything. I'm gonna save the game mode, close everything, and I'm gonna click there to open the character. So that has been written by the template. Okay, so let's look at how it works. We have here in this class the asocialmix intro character. We define, because we're in the .h, we define the different components that we enforce. Okay, so we have a camera boom that is a uSpring arm component. Okay, and we define it, and it's a pointer, as you can see. And we declare it there. And we put this sort of, again, macro on top to bring extra management from Unreal regarding this pointer. The uProperty macro does two things in this context. It brings you some tags for you to, in the editor, see the value. For instance, here it's visible anywhere. It's not editable anywhere. It's visible anywhere in the sense that we can view it. Okay, so that's why we can see it in the editor. We can see the boom here in the editor. Okay. Then we have blueprint read-only, meaning that we cannot set it in blueprint. I can read it in blueprint. So if I go there in the event graph, I can grab the boom. Okay, but if I want to set the boom, or if I write camera boom directly there, you can see we only have camera boom. We don't have set camera boom. Okay, if I want to change it, I can. It's game code. I can say read write, Control B. It's taking a bit longer, of course, because we're changing something more raw in the hierarchy. If I come back there, now I have boom. If I type boom, I can set the camera boom. Okay, and I can also press Alt and drag to set the camera boom. That's my choice. Okay, I can do that. But in the template, they decided to make it read only. You have to learn the macro, or you have to have Visual Assist to assist you with blueprint, read only, etc. Okay, this is not something that Visual Studio is going to give you by default. Okay, so let's put it back to read only. Then you can set up a category. And also because it's in the private section, by default, if you don't have public or protected, it's in the private section. That's basic C++ stuff. You can also have this very weird and strange syntax saying that even though it's a private property, it's still accessible in the editor. Okay, because this is Unreal, it does whatever it wants on top of the C++. Okay, so you can say, please allow the access of this variable, of this property, even if I'm in private. Okay. If this wasn't true, if I didn't have that and I would have compiled, you can see I have an error. Blueprint read-only should not be used on private members. So I cannot have this tag without specifying that I allow the property to be accessed being private. Okay, so I have a property, a uProperty tag. And so that's the first thing, giving the accessibility of the variable. So that's the first thing. The second thing is that it helps you manage pointers automatically, in the sense that because this variable is a uProperty variable, automatically Unreal behind the scene is going to manage the life of this pointer. I will never have myself to do a delete. Okay, you know in C++ when you do new and you instantiate basically a pointer, you have to manage the deletion of the pointer. or you're using smart pointers, but you can use also smart pointers in Unreal, but here it's even simpler. You just say it's a pointer and then you don't care about that Unreal when the object is going to be destroyed. If Unreal thinks it's the right time to destroy the memory of this object, it's going to destroy it for you. And this is because it's using what we call a garbage collector that you may be familiar about with, you may be familiar with that concept from C# or Java or other modern programming languages. Basically, Unreal has a tool internally that is a garbage collector that is allowing C++ to use it, okay, to use a garbage collection. The very simple idea is that it's looking at the variables that are set as U properties, and from time to time it looks at the number of objects that are referencing those variables, and if there's nobody using this and it makes sense to delete it with lots of rules, it deletes it, okay, from time to time. So that's something to know. As you can see, then we have another U property, okay, called follow camera. By the way, the class here is because we're forward declaring this class. So as you can see, we're not including uSpringArm component because we don't want to include it in the .h, of course, because it's going to introduce more build time. But we are forward declaring it, saying that don't worry, you're going to see this definition later on in the process, in the compilation process. Okay. So it allows us to be faster in terms of building time. But in the C++ file, you can see that we are a camera component, SpringArm component, we are actually including it over there. Okay. You can also forward declare, by the way, by using class like this and a semicolon at the end. It will work too for the whole file. It's quite neat. And again, if I forgot to forward declare a class that Unreal that is not included, I have an error there. You can see the error is in the .h, like here, missing blah 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 before blah blah blah. In fact, he is lost, like it's lost. It lost the track because it doesn't know the type. So let's forward declare it again. Okay, and I compile and it works. So we have the camera boom. So the camera boom is this object. Okay. Now we have the follow camera. So we declare a camera. Okay, and this is this object. And then we declare the default mapping context. And now the default mapping context is not a component. It's something that is there and should be seen, blueprint read-only, and editable anywhere. So it means that somewhere there we have this object available for us. So let's filter and let's find default mapping context. And you can see it's under the input category. Why? Because it should be here called input. You can also put that in as a string if you're okay. But with a macro, you can save some time and not, yeah, whatever. You understood. So here we can set it, and we set the type of IMC default because, as you can see, it's an input mapping context sort of object. Okay, so we can set it there. Then we have jump actions, move action, look actions, and those are input actions that we can set up. And if we filter now by the category input, you can see how jump action, move action, look actions are available for me to set up as a designer or at least in the editor. Okay. So that's quite great. We understood more things. Okay, now the components here are just pointers. They are not created, they are not instantiated. How are they instantiated? So first, we see in the editor that they are instantiated because they exist over there. We see them. So it means that they exist in the context of the runtime of the editor and not the game. Okay, they exist, of course, in the context of the game, but also in the editor. So it means that probably it's in the constructor of the C++ class. Okay, if we look at the C++ class, oh, we have a huge constructor there that is actually setting the camera boom there. So if we look at the camera boom, you can see that the pointer is created So we create an instance and we affect it to this pointer, camera boom, that is, remember, stored there. And there is not a new there. We don't use new very often in the engine, almost never. We always use functions from the engine that generates the object because of memory management and lots of things, okay? So if you want to create a component or what we call a sub-object, also we can do that. So because we are in the character class, we want to create a sub-object, so an object in the hierarchy of type uSpringArm. So it's a template, as you can see, and we put the name of the object. Usually we wrap it in the text macro, but if you want, you can avoid wrapping it in the text macro. It will do the same thing. The name that you see there, if I change it and I rebuild, you're going to see it's actually the name that appears, that will appear in the hierarchy. So I guess I have to reopen the blueprint, or I will have yes, you can see now it changed. Camera boom high. Okay, so that's just a label if you want. So let me rebuild to remove that. So you can see I create an object, but that's not we must do something more than just creating an object, because now at this stage, line 40, we create the object in memory. Okay, but it's not part of the hierarchy of the components that we see over there. So we have to attach it to something. And we attach it to using the setup attachment functionality, and this comes from probably the base class of a component. Okay, so if we look at there, we go up in the hierarchy and we can see that it's part of the scene component, okay, class, which is logical because this is something that we want in a hierarchy, and a scene component is something that's visible, that has a transform, and that we can attach to another component that is another scene component. Okay, so we set up the attachment to the root component. The root component is something that every actor has by default, is the root component. Basically, it's the component that's the top parent of the class, and that can be set up, that can be defined, overwritten, sorry. And if we look here, they decided not to override it, but we can say that one component is if we want, we can say that the capsule component is the root component. Let's do that, for instance. And in order to do that, I just say, you know what? The root component is the capsule component. And from where capsule component comes, it comes from the character class. Okay, it's a variable that is inherited. So if I build that, I cannot access the private blah blah blah. So I usually have a get capsule component that it's a getter and a setter. But if I do that, you will see that the root component will become the capsule. Okay. So it's built. If I come back there and I save and compile and restart the thing, because sometimes it's not working. Okay, maybe I have to restart the editor. So let me save the selected things and relaunch the editor by pressing Ctrl F5 this time. Sometimes when you're doing changes inside blueprints, like in the hierarchy, you have to restart the engine actually. I know that's weird, but you have to do that. And here you can say, yes, please reopen the last things that were open. And apparently the BP was not opened. So if I open the full blueprint now, you can see that still, apparently it's the default already. You know, I cannot read. I thought that, no, sorry. In Unreal 4, this was replacing the top parent, but you can see that this is the default root component. It cannot copy it, rename, or delete it. But basically, it's probably somewhere in the code. It's probably doing the same thing. And you know what? Because I'm very curious, I'm gonna do that. I'm gonna press Alt Shift S, which is a Visual Assist shortcut, and I'm gonna press A character to find the symbol in the engine A character, and I'm pressing Alt-O to look at the CPP file, and the root component, as you can see, is the capsule component, okay? In the engine, this is in the engine. So I was right about that. So we don't have to do that again here. So basically we are attaching the camera boom to the root component, which is true. You can see here the camera boom is a child of the capsule component. If we look at then we set the target arm length, which is a property of the camera boom, which is the distance to the of the stick, and it's for 400. And if we look at there in the camera boom detail panel, let me come back over there, and the camera boom, where it is? It's there. It's read only. It's visible anywhere, so let's, instead of making it visible, let's make it edit anywhere. So we have now possibility of changing the values, properties. It crashed. Control F5. And back there, let's open the blueprint. And apparently I still don't have access to the variables, so let's I made it edit anywhere, private access. Let's make it blueprint read write, but it shouldn't be the issue actually. Sometimes it's reacting weird when you don't see the... Yeah, you can see here in the mesh, I can see the information, and not in the... And the mesh, let's... Usually that's great because we have the source code, so you can always reference the U properties the way it was done in the engine. So here, if I look at the mesh, you can see it's visible anywhere, blueprint read only. Okay, that's quite strange because we could have access to that, but apparently the camera boom don't want to give us access. So let me build again with exactly the copy of the mesh. And I don't have the details over there, which is quite strange. I must say, I don't understand why. So sometimes you have also to rebuild the solution. So I'm going to show you how to do that. Let's try to see if it helps. So I right click on any assets and say show in folder. Show in Explorer, sorry, and I come back to the contents, to the project, and to do that you have to close the editor, and what I do is I remove intermediate, derive cache, and saved, and binaries. I delete those folders, so intermediate they don't want because apparently I need to close Visual Studio 2. And then I delete the solution also, and I right click and say generate Visual Studio project files. This is gonna regenerate the solution. It's something that you can do when you have something that you don't understand in the engine, that it should work and that you're close to sure that you haven't made a mistake. Then you can restart the solution. And when you're ready, you can press Ctrl F5 in order to start the engine once again. Okay, so I was facing actually a strange bug. So I tried many things off camera just to show you, to explain to you my process of work. Like, it's actually like it should be working with visible anywhere, like getting the properties of the U properties, but sometimes you think it's not because it's actually not working after regenerating the files. But actually the name, I changed the name to camera boom test, for instance, and now it worked. So there is definitely something in the engine that was wrong using camera boom, the name, or something that stored somewhere camera boom without the right without the right U property definition. So yes, that's why I wanted to say that. So in order to make it work, Alt Shift R in or Control RR in Visual Studio and Alt Shift R in Visual Assist, and let's rename it Spring Arm so it's a different name. And yeah, it's quite strange, to be fair. I'm not sure why, but sometimes, and it's very rare, so I have no chance when recording this tutorial. But that's good that you're seeing how to go out of a bug like this, because you're gonna sometimes have some of this in this engine. But try renaming your variables with a different name, and please do a battery name, like using a tool, like instead of by hand. And now if we open the blueprint, it should work. You can see how we have access now to the variables of the Spring Arm. So quite weird. At least you have one solution. If you know how to work from where it can be, even though I regenerated the solution, please tell it in the comments. So you can see that I have the target arm length here variable that is set in the constructor to 400, and if I override it there, I change it from the default constructor value. I can click reset this property to what has been set in the default constructor, of course. So if we come back there, that's the length of the arm, and if we go in the viewport, you can see it change real time, okay, which is quite neat. And here, that's where we start to have our first gameplay stuff into the mix, which is quite neat. You can see that we say to the Spring Arm to use the control rotation. Okay, so if we look at the Spring Arm object, it's using the pawn control rotation, sorry, not the Spring Arm control rotation. So now we are diving more into the gameplay framework of Unreal. We have, again, a player controller, which is what we call a controller usually, but more specialized, or a player controller, so it inherits from a controller. And a controller, as I mentioned, is going to possess a pawn, so being the brain of a pawn, it's going to be the brain of a pawn. And a character, remember, is a special pawn with more possibilities. And by default, all those components are there in this pawn. But at the core, a character is, in the end, a pawn that is possessable. So we have here this variable that says to our pawn, we need to find the controller that controls the pawn and rotates around in the same way that the controllers rotate. So again, a controller, imagine, is an invisible object in the scene that we saw, okay, but it has a rotation. Okay, it's not located somewhere, but it has a rotation. And when we move the mouse, what we do is actually we rotate the controller rotation, so the invisible object, and we ask the pawn, and especially the Spring Arm inside the pawn, to use the controller that possesses the pawn, the controller's rotation, sorry, that possesses the pawn. I know it's a bit weird, but that's what exactly this tick is doing. And if you look at that, if the component is placed on the pawn, it may be not, but if it's the case, which is the case already, we need to use the view or the control rotation of the pawn where possible. So we're gonna override the rotation of this object, of the Spring Arm. Okay, you can see it's locked, probably it's due to that, I don't know, but yes, it's due to that, as you can see. We are using the controller's rotation and overriding the rotation. So it means that somewhere in the code, we have some bindings to inputs that rotates the controller. So in the end, the arm spring uses this rotation. Okay. So if we go in the code, and just before going into that, then we create a camera, same thing as before. We attach it to the spring arm using a socket. Okay, so the socket is something very simple. It's at the end of the spring arm. There is an invisible position called the socket. Okay, and this is where we attach ourselves. Otherwise, you don't know that it needs to be at the end of the stick. But easy stuff. Okay, and we say that the camera here in this context, you can see we say, please stop following the rotation of the controller. Imagine the stick plus the camera rotates, it's gonna be a mess. Okay, so how does the controller rotates? And that's where we need to see how the inputs are binding to rotate in the controller. Okay. Characters, they have a function, okay, that's called setup player input component that is virtual, so we override that. And what we get from this function is what we call the player input component. And the player input component is being fed from the controller. Okay, so we have the player input component over there. We are casting it to the enhance input component, which is the new type for the input component in Unreal. And as its name suggests, input component is really an input, like it's really an input component. It's really a component, sorry. And as you can see from there, like, I mean, if we look at the code, we can even, you know what, something that's gonna be super nice to do. I'm gonna close the engine, save selected. I'm gonna put a breakpoint over there, and we're gonna see in debug mode, so I'm gonna click this arrow, how we come to this, okay? And you're gonna see it's quite marvelous to see that and be able to do that in the engine code, seeing the call stack. Okay, so I play the game, it stops, of course, and then we should have the call stack. It's external code, okay, it's not working. That's bad news. So maybe I don't have all the symbols ready. But at least we know how to debug now. In any case, I need to stop because it's gonna kill the engine, the editor actually, and I need to restart the engine by pressing Ctrl F if I don't want to be in debug mode. But the thing is that we can still investigate and see where this setup player input component is being called. So let's do that in the code base. It's going to search for a long time, but we're going to press Alt Shift F on top of this method. And we are searching in the solution. It's going to take a while, but it's going to show us who is calling this functionality, this function. And here in pawn, we have this. So let's look at this. And it's apparently the pawn that set up the component, the input component, and the input component is created over there, so it's not the controller, it's actually the pawn that has the input component. And here the input component, as you can see, is created using a new object, which is the equivalent of new in the engine in C++. And we create this input component, and we directly we transmit it here when the client restarts. We transmit it and we set up the player input component. So as you can see, there is probably another point where it's set up, but I cannot find it right now. But as you can see, we can find in the engine where it is. But still, we have the input component, not from the controller, sorry, it was a mistake. again, that's why I wanted to check, but it's the pawn that is actually creating the input component. Okay, so this input component, we can bind now actions to them. And how do we bind them? We use this object that we cast actually, so because input component is a base class of a enhanced version of the input component. And then we bind some actions. Okay, and now what we want to do is just look at the mouse, because the look, because we already seen that before and how it was set up. But here we see we bind an action to look action. Look action, remember, we already defined that in the .h as a u input action. And how do we set up it in the blueprint over there? We can look at the input, and you can see it's there. So this is this class, okay, this struct, sorry, that if you recall correctly represents an axis 2D, so a vector 2D. So if we bind an action, we bind it to this action. We say when the object is being triggered, then we're going to call a function. Okay, so when we trigger this input, basically, we call a function. And which function do we call? We call a function that is called look, and this function is on which object? It's on this object. And this object should, therefore, which is the SocialMix intro character class, should have a class, a method called look. And this is the case. And it takes one parameter, okay, because when we bind an action, it takes one parameter, okay, and here we're only giving the pointer, the address, sorry, of the function, okay. It's, as you can see, the prototype. Come on. Okay. You can see that we have a f input action handler signature t method pointer. So it's a pointer, it's a method pointer. That's why we are sending a method pointer there for the address of the function in this context. And the look function, if we look at it, each time we trigger, in this context, the mouse motion or the gamepad right stick, we are getting back a value that is a f input action value. So this is still abstract. We don't know exactly what it is, but we know what it is. We know that it is a vector 2D. So we are getting this value, and from this we are getting the actual data that should be of type f vector 2D. Again, f vector 2D is a struct. Usually, as I mentioned, f means it's a struct, and it's really a vector 2D like x, y, and that's why we are extracting from the data that we're getting a vector 2D. Then here, if we have a controller, and that's where it's very interesting for us with what I mentioned before. If we have a controller, okay, if the pawn is being controlled, therefore is being possessed, okay, if this character, which is a pawn, if it is being possessed by a controller, in this context a player controller, but we don't care about the specificities that it is a player controller, but it's a controller. What we do is we use a function that is going to add some input in the yo part of the rotation. Okay, so remember yo is the z-axis, the rotation around the z-axis, in this invisible object that is the controller. Okay, so we're going to add controller yo input passing the x-axis of this input, which is the x motion of the mouse, or the x right-left motion of the stick, right stick, to the controller yo input function that in the end, if we go to it, you're going to see it's in a pawn. It's going to grab the player controller, okay, of the character, of the pawn, sorry. So if we don't possess this character, if the controller is not putting his brain in the pawn, this is not going to be valid. Okay, so we are not going to have a player controller. Okay, in this spawn, this value controller is not being. It's going to be null. Sorry. Okay, if this is the case, what we do here, because we are sending these values, so in this, if we follow the path, we were sending the x axis. If this is the case, for the player controller, we add a yo input, and if we go there, in the player controller, we increase the rotation input vector, okay, a rotator, sorry, yo axis. Therefore, therefore the z-axis. So we've been in a rabbit hole in this context, but the controller has a variable called rotation input that is a rotator representing a rotation, xyz, and each time we move the mouth, through the pawn, we get the controller and we add the value of our motion, x-axis in this context, to the yo of this rotation. Okay. And remember that we said at some point in the stick, if we come back there, in the spring arm, that please use the rotator or the rotation of the controller if there is a controller. Okay, and this is the end of the loop. As you probably have understood, we have over there used, the stick is using this property in the end. Okay, so through the character, if you come back, through the character, when we're setting the input, we're binding the input to a function. So each time we move the mouse, we trigger this function. When this function, it receives the axis value that is still abstract. We are getting the axis actually. We are specializing. We are sort of casting, if you want, this to a vector 2D. We know it's a vector, so we're just getting it using a function template that's going to cast it to a vector. If you look at it inside. Let's not look at it because it's already a huge rabbit hole. But basically, we are getting back the axis, and then if we have a controller, okay, meaning we are currently processing this actor, as it says here, like the controller that is currently processing this actor. If it's the case, then we add to the controller some rotation, okay. We add, to the rotation of the controller our value for this this axis on the x, and you can imagine that we do the same for the pitch, which is looking down and up. Okay, the pitch is looking up and down. So if we go there again, same rabbit hole. We add to the player controller if it exists. Of course, if we are a player controller processing this pawn, and then we go there, and you can see we do this, and we do a little bit more because. Some checks and some input settings and lots of things. Okay, but that's the general idea of it. And of course, we ask the spring arm here to follow the rotation that we set in the controller, which again is this actor floating in space, invisible in the scene that actually has this rotation. This property of rotation that we use here and there. And we specifically in the camera said and forced it in C++. That's why we don't have the tick to change it back to default, or the reverse if we make it true. But we said here, please don't use the rotator that we saw in the controller. Otherwise, you're gonna also rotate the camera itself, which we don't want because it's attached to the stick. Okay. Whew. It's been long, but we understood that we have a character that spawns, that makes sort of sense, okay? And we also understood how the magic of the binding works, okay? So let's come back. I don't know why now it's not working anymore. Let me try to fix that. And I was right, I removed the mapping. Okay, so if I remove the mapping, here by mistake, here I cannot cast. Okay, so the cast failed. in the setup input component, and therefore I cannot cast it to an enhance input component. That's not actually. Yes, sorry, player input component is null, therefore I cannot cast it to the enhance input component. So let's bring it back. So now we understood that how this is possible to rotate around the character using the stick arm, the actual setup of the inputs, and also how the pawn, so the character in this context, so a specialized pawn, is feeding the input to the controller, which is the invisible thing that we are as a player. That's the representation of the player, if you want, the brain, feeding its rotation, so lots of other things can use the controller to get the rotation and to get the viewpoint and etc. etc. And in this context, the spring arm will look at the controller of the pawn in order to grab its rotation and rotate itself. Pretty magical, right? And if you follow this logic, now we have for free lots of stuff. So in the spring arm, for instance, we can look at the lag. So we have camera lag, okay, and this is a free lag that we can add. So I can set up the lag speed. I can say it's very laggy. The rotation speed is also laggy, and if I do that, when I open, you can feel. I cannot feel it very much. I need to compile. Maybe I need to add more lag. Okay, so its smaller value are more laggy, so let's put 5, and here let's put 5 also. You will see it's very laggy. And now, I don't know if you feel it through the video, but I just move my mouth and it comes later on. Okay, so it's very laggy. Woo! Even the rotation is very laggy. This is motion sickness. I don't want to do that. So let's remove the lag, but you have tons of stuff for free. And the spring arm component is using its camera if it exists. So you can see if true, camera lags behind the target position to smooth its movement. So it's grabbing internally the camera that is attached to it and making it lag, probably with some linear interpolation and some slurp for the rotation. Super cool. So we know how to set up a basic rotation for the camera. Now let's look at how this character moves, which is quite neat. So it's moving through the character movement component. So let's go back to the code and let's analyze how it works. So now we've seen how to look. Now let's look at, before that, let's look at something very simple, which is the jump. Actually, because we are in Unreal and we have the luxury to have the character class, we can bind directly the jump action directly to the jump function, which is a character class that is already handled for us. So behind the scene, it sets up the Boolean press jump, and in the tick function, it will look if we have been pressing jump, then execute the velocity, set the z velocity to the jump value, and do process the physics and things like that. Okay. And the stop jumping is also a function from a character class. So you have that actually for free in a character. Okay, and that's why here we are looking at the a character class and not the a social mix intro character class, but we could have done that also directly. Okay. If we do that, it's just going to look at through the inheritance for the jump class. Okay, and you can see it's very easy to bind an action this time. We bind the jump action when it's triggered and when it's complete. Okay, when we release basically the jump. So that's quite neat. I can also create, let's say, a function myself. So let's say I want a onJump function. Okay, I'm gonna create an implementation for this one. So that's the neat thing with Visual Assist. You can Alt-Shift-Q, and say create implementation. It generates the implementation for you in the C++ file. So now here I'm gonna replace the jump with onJump. okay, which is now going to be in my class, like direct in my class. So if here I'm calling the jump function, which is in the A character class, I can have the jump, and let's say I want to do something else, like I want to log something on the screen, so I can use my macro, visual assist macro, and say jump, for instance. Sorry, without parameters, I can say jump, and if I build, I'm going to jump and add my own logic on top of that. But basically, it's the same concept. I'm binding a function to an input. Super easy, right? Jump. Yay! Okay. By the way, you can see how this is, because it's the trigger function, we don't see the it's a perpetual, like it's perpetually triggering the action. So that's a good also introspection into how it works behind the scenes with the input system. Okay, quite nice. We've learned some new stuff. Let's come back. So the jump is quite easy. I'm just gonna remove my comments because otherwise it's gonna be very bothering, I think. So let's look at the move. So the move, we are binding an axis, we know that already, and we are binding it to a move function. So the move function is defined in the.h, receiving again an input action value, so the abstract idea of like a value from the input. We probably know that we're gonna get a vector out of that, so same thing as in the mouse. And now we look if we have a controller. And why? Because if we analyze from a gameplay perspective what we're doing, we are using the direction of the controller to orient the character in this direction. So when I move, if I don't move my mouse, you can see that I'm actually going in the direction of the camera, of the viewpoint, which in the end is closely related to the controller rotation, because the camera which is attached to the stick, and the stick rotates itself according to the controller's rotation. So therefore the camera is closely related to the view direction. Okay, so that's from a gameplay perspective. When I orient the camera, the character moves in the direction of the controller. So that's the behavior. So let's try to analyze how it's done. So if we have a controller, that's quite important. What we do first is we get the rotation of the controller. Hey, why? Because we want to match the direction of the controller, and we generate we get the rotation over there. And if we look at get control rotation, what it is doing behind the scenes, it returns directly the control rotation. Okay, and the control rotation, as we've seen that before, is in the controller, is the control rotation. Okay, let's come back. What we are doing now is we are creating a new rotation, new rotator, based on this, because the control rotation, we recall that we also had the pitch, so the look down and look up. Okay, we don't want that, because we don't want to, if we're like this, we don't want the character to move, we don't want the character to move, up. Don't want the character to move in the ground, like this. We want the character to only follow the controller's rotation forward, but we don't want the up and down motion of the controller. So that's why here we are creating a new rotation with no pitch and no roll. Okay, but we're getting only the yaw. That's actually great. And if you look at the way the rotator is constructed, here we are setting pitch, yaw, roll, which is actually Y, Z, and X. It's not X, Y, Z, which is a bit strange. Like when you start, you're setting the pitch, yaw, roll, so not X, Y, Z. Okay, so So that's why we think that this is the y, which is indeed the z. Okay. If we look at the gizmo in the scene, this is like z up, but this is actually what we're setting up there by putting it as the second argument. So from this rotation, now that we have a rotation that is only 2D, okay, not pointing in weird pitch direction, what we want to do is to get the x-axis of this rotation. If we look at a rotator, it has a basis which is like a direction. Okay, so imagine that you have a rotation, but this rotation has a forward vector, a forward direction, and this forward direction, in the context of Unreal, is the x-axis. So forward for Unreal is x. In Unity, for instance, it's z, but in Unreal it's x. Okay. So using the math library, we have something called F rotation matrix, okay, which is a matrix math and linear algebra, and I'm not going to enter into too much detail, but what we do is if we pass the rotator to a F rotation matrix, we then have a utility function that is returning one of the base axis of this matrix, which is the unit axis x in this context, because this is what we are asking for over there. So we ask through this enum, please give me the x axis from this rotation. Okay, and we know from what I explained before. So if we go there, you can see we are getting the axis, getting the normal of blah 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 blah, and getting the scale axis, which is going to return you the component of the matrix corresponding to the x-axis. As you can see here, it's this. So lots of math, and you can thank Unreal for having that written for you already. But basically, we're getting the forward axis of this rotation, so the direction that points forward from this rotation. Okay, so this is the forward direction in the end of the controller. Okay, and we can also grab the right direction of this controller. Okay, remember the controller is the brain floating invisibly in the scene, but that is not there and not moving. Is the concept, of course, of the player, but basically we're getting where it's pointing forward and where it's pointing right this time, because the x-axis, the context of Unreal, is the side, is the right vector. Okay, in Unity is x, but that's the coordinate space of Unreal. Okay, so we want this vector basically, and we want this vector, okay, of the pawn of the controller. Okay, and then because we have those vectors, what we do is we add movement input. Okay, what is add movement input? Add movement input is a function with a long description that basically, if you are from character, and why it's from character, like the class character, it's because character has a movement component, a character movement component. It has this thing here that is pure logic. And the logic of this is to get the input vector, and the input vector corresponds to a vector that defines the direction basically of how this whole character should move. Okay, so what we're doing with this movement input function that is in character, the character class, I am actually feeding the forward direction. Okay, and here I'm feeding the movement vector. So if we look at it, is what is the world direction, the first parameter? Okay, forward, it's the forward direction, therefore of the controller. And what is the scale value? So the scale value is, should we follow the direction forward or should we follow it backward? And because the movement vector here represents, if you recall, that negative sign is backward in the axis, and we've seen that in the inputs previously, in third person, inputs, IMC, mapping, move, S, which is for me backward. Here you can see that we negate the axis. So if we negate the axis, here that's the scale of the vector of the forward direction. So if I press S, I'm going to go in the opposite direction of forward, which is backward. Therefore, I'm going to move backward. Okay, or at least I'm going to set the input vector, the input movement vector, to backward. Okay, doing the same thing for the right direction, which is therefore the x-axis. Okay, and how it's set up. It's set up with the Q and D in my context, but it should be WASD, I don't recall in English, but it's basically also the right and left key. So in the add movement input component, if you look into it, we add the movement input component, and you can see that in the movement component, which is the movement component that we've seen before, which is this one, what do? We add the input vector, which is the world direction, which is the first parameter we sent, times the scale value, okay, and if we use the force or not, but we don't care about that for now. If it's the case, we add to the component, movement component, the world vector that we've computed. Let's go with the next thing. We go there, and in the end, what we're doing is just moving, like adding to a simple vector. Okay, and this vector, which is control input vector, in the end, as you can see, it accumulates control input vector stored in world space. This is the pending input, which is cleared, zeroed out once consumed. So it means that probably in the tick of the component, movement component, we're going to use this vector to somehow move the pawn that is the pawn set up to this component, this movement component. So the movement component references the pawn in which it is attached, and then the movement component through this control input vector, which is the direction basically of the pawn that we want, is going to move the pawn basically. Okay, and we can probably look at this value if we go to the. I imagine we have the tick function, the tick component function somewhere. Tick, or maybe it's used by another component that's grabbing this control input vector. But I'm pretty sure that if we look at this symbol somewhere, we're gonna find it in a math equation that basically will multiply it by the speed of the movement character. Like if we look at here, controller, we are zeroing it out over there, and we say, okay, the last, so now it becomes the last control input vector, so that's the variable that we should track. Let's track this one, therefore, which is probably going to lead us to, so, and you can see that we are in the pawn now, okay? And you can probably look at, in the pawn, let's come back to the movement component. We are in the pawn, we add to the movement component, which is there. Control, we don't have a tick. We don't have a tick, but we have like move maybe. Oh, it's going to be long, but we have get pending input vector, return the pending vector in wall space. This is the most up-to-date value for the. Donc, here, if we look at this, probably this is going to be the last, the control input vector, indeed. And if we look at who is calling this, we're gonna probably find how the pawn is actually moving, which is exactly what we're looking for since the beginning. Get clamp to scale, probably in there. Apply control input to velocity. Here you can see that we are actually getting some variable that are looking gameplay-ish, right? So it's probably getting in the floating pawn movement component, which is what's the character movement component inheriting from. So if we look at the character movement component here, you're gonna see that it's inheriting. Look at the component. Public, blah blah blah, class. Sorry. Oh, I mean the character class. So movement component, uCharacter movement component. You're gonna see it's inheriting from uPwn movement component, which probably here, I don't think I have a tick in there too, but this is inheriting from uNav movement component. Probably this doesn't have a tick neither, and this is from, this is ticking. Is it ticking? Is it a component? It's a component. Is it ticking? It's ticking. So if we look at there, inside, we set update component, and it's probably somewhere there. I don't have the time to see that. I recall having done that in the past, but I relied so much on the things working. But you can see like the thinking and the thoughts that I have when I try to search for something. It's probably going to take 15 minutes or 20 minutes to find the things that I want to search for. But you understand the logic. The logic is that we have different objects that are like intertwined and like are setting data on top of each other through functions that are there for us, that in the end works behind the scenes with the math and the things like that. So please, when you're building gameplay, try to understand the gameplay framework first, and that's where you have to look at the documentation of Unreal and the API to see if it already exists or not. And again, it's not only motion that you are getting for free there. You're getting all of this, all of those parameters. So if you want to make, for instance, gravity close to zero gravity or something like that, you can say the gravity scale now of the character is instead of 1 point blah blah blah, you can put it at 0.5, and if I simulate and jump, you can see how, because I've used the character class, I now have a sort of zero gravity style or moon style of jump, because I'm sending the input vector that in the end, somewhere in the engine related to the character class is, and sorry, not the character class, but the character movement component is computing the logic for my motion. Okay, if I want to, for instance, bring more air control, I can say, okay, I don't want air control at all. Okay, so 0. So now when I move, you can see how I stay where I am if I don't have the input velocity in a direction. But now let's say I want full air control, I put it to 1 or even bigger. You can see how now in the air I can move. So you have tons of parameters and functionalities ready for you in the engine. So let's say you want a more strong gravity. Now you jump way less. So you can go here in jump and say, okay, the jump z velocity is going to be doubled, so I multiply it by 2. So now I can jump twice as high. And this is where Unreal Engine becomes magical, when you understand the framework and you follow the framework. It's the fact that you can actually use tons of bricks that are already existing and are well made by pretty good engineers, actually. So we now understood like the whole template, actually. I've came across the whole template. There is one other thing that we haven't seen in the begin play here, is that we are actually grabbing the controller, okay, so the brain of the player, and we are saying to the subsystem of the input. So a subsystem in Unreal is sort of a singleton class that does something globally in the engine, or that is accessible globally in the engine. So that's why you can say get subsystem in order to grab different sort of subsystem. And there is one that is called enhance input local player subsystem that basically your needs when you're getting it needs the local player. When you're getting a subsystem, it returns the subsystem, and then what you have to do when using the new input system of Unreal 5, you have to map the context, and the context is, if you recall, the object that we've been using on the character itself over there. Okay, so it's the default mapping context that creates the link between the actions and the key, if you recall, and negates and do modifiers and things like that. Okay, so that you have to do that at begin play, which is again a virtual function that it's like the start function of Unity. It's the initialization after the constructor, but when gameplay wise, it's when you start the execution of the object once you have this event being sent by the Unreal Engine, and you can override it. So now that we've seen all of that, and of course, yes, we have to notify the subsystem that we need this mapping and that this is the mapping in question. Okay, so now that we've seen a bit of things, I'm just going to recompile because I don't want to see the debug screen message. So the last thing that we'll have to learn from this template is how the animation system has been set up, and then after, as promised, we're gonna try to implement some gameplay mechanics on top of this template to learn a little bit more about the engine. So if we look at the animation part of the blueprint, like the mesh actually, we can see that we set up the mesh as a skeleton, as you can see over there, asset. And if we come back to the character, and if you look at the mesh, which is in the character class, sorry. And if we look at mesh, we can see it's a uSkeletal mesh component. Therefore, it means that we can only set up a mesh that has a skeleton. And if we look at it here, you can see that we asked for the SKM underscore Quinn symbol. And we also have here for the animation, the use of the animation blueprint. We could have said use only one animation. Okay, so we may, for instance, here pick an animation that fits with Quinn. Let's say Quinn. Actually, the setup is a bit different with this, so let's switch for another character. Let's grab Manny. Okay, and with Manny, we're gonna try to bring run forward. So you can see that we can, as you can see, set up one simple animation, or we can use a blueprint. And with the blueprint, we have many blueprints possible. Let's grab ABP underscore Manny, which will be the simplest one to explore actually. Okay. So as you can see, we switch the character from a female to a male, and we're gonna explore the animation blueprint. So I'm gonna compile the character, double click on the SKM asset to open Manny, and here you can see that we have a short way to go to the last one, which is an icon with nodes that represents actually the blueprint for the character. The animation, sorry. So animation blueprints are like blueprints, but very oriented towards animation systems. So you can see we have two things mainly. The first one being the event graph, where we compute data that is meant to be used in a state machine of nodes of animation. And the animation graph here is where we define what's the final pulse per frame is. So we're gonna, we cannot disconnect that for now, but we're gonna understand what it means later on. But here, as you can see, we have the locomotion state machine. If we double click there, we have what we call a simple state machine, where we have one state and you can add more state by right-clicking and adding a state. Okay, and a state, if we double-click inside it, it's just inside an animation. Okay, and if we double-click here the animation, we see that this is the idle. Okay, so here, if I want, I can remove it, and if I want to bring it back, I can put the animation and then grab the pose and output it to the output pose. Okay, super easy to do, and as you can see, this is the same idea that we had before. Then we have another state, which is what we call a blend space. But before understanding what the state is made of, we need to understand how we transition from state 1 to state 2. So if we want, we can drag an arrow from the outer edge there to the new state to create a transition, as you can see. And this transition there, if you double click there, you have a condition to move to the next state. So here the condition is should we move, and should move here is a variable that is there, and that is probably set in the event graph over there. Okay, so should move will be a variable that is defined according to the fact that we are accelerating or not. Okay, like the ground speed should be above than 3, and the current acceleration over there should be okay, returns true if vector A is not equal to vector B within a specified error tolerance. So, and the current acceleration is not a 0 vector. Okay, so basically we have acceleration and the ground speed is above 3, then we set this boolean to true. Okay, if it's true, we can, as you can see here, go to this state, and we come back with the hierarchy over there. So the anim graph, then we enter, and then this transition will transition, of course. As you can see, we have details for the transition. So the main condition is should we move, and then we also have duration, for instance, of the blend. So how does the one animation blends to the other one, and that's the duration of the blend. And from going to walk, from walk, run to idle, shouldn't we move? If we shouldn't move, then we should go back to idle, which makes sense. Okay, so let's look at the strange state. Okay, we have inside what we call a blend space, and if I double click, a blend space is an asset, okay, that allows you to put multiple animation on a sort of track, on a sort of line, if you want, and depending on where you are on the line, on the axis, it will play a different animation. So here, if I press Ctrl to preview, you can see I have 3 animations, the 3 keys that are actually animations, okay, and I can put more of them if I want, you can see. And when I press Ctrl, it previews how it blends from one animation to another. Okay, so you can see how from one animation to the other. And if we play by pressing spacebar, you can see how everything blends together. So this is the axis, and the axis over there is defined in the horizontal axis. It's called speed, the axis, and speed is exactly what you are looking at here. It's the name of the variable. So if we feed speed, the speed variable, on this axis, that goes between 0 and 500, and let's say we input 100 and 200, for instance, here it will be looking like this. Okay, if we go 500, it will be looking like this. If we go 0, it will be idling. It will be sorry, in this context, walking a little bit. Okay, so ground speed is actually the data that we feed to the blend space in order to control where we are on the line, on the axis. Let's move back. And therefore, in the event graph, I have to calculate ground speed. And ground speed is simply calculated by grabbing the velocity vector of the movement component, okay, which is basically the direction scaled by the speed that we define in the character movement component. we set the velocity, and we grab also the length on the ground. As you can see, we get the length, but xy. Okay, we don't get the length if the velocity vector is pointing up. We don't care about the fact that it's the components going up. We don't care about that. We project it on the ground, and we get xy, and that's why we are using the length without taking into account the z, which is up in Unreal Engine. So basically, we're using a 2D vector projected on the ground. Like the velocity is a 3D vector, but projected on the ground. And this is how we set the ground speed that is being used later on in the anim graph. And the whole locomotion system over there is cached in what we use, a cache. Okay, so locomotion is a cache, so it means that we can use it later on. So if I delete and I recreate it, I can tap cache and new save pose, and this new save pose I can call it locomotion, something like that, and you can see that it can be reused. For instance, in the main state, I don't know exactly, locomotion here, it's used there, and if I deleted this and compile, I would have an error, of course, telling me that I'm using a cache that I don't have. So here, when caching the animation, if I call it locomotion, I compile, it's working back because it's the same name, it's trying to find a name. And in this state machine, which is the main state machine, okay, this is running, okay, like this is running on its side, but this is not outputting to the final output pose, the one that we see. Okay, this is being used inside the main state over there. So here we have the locomotion system that just outputs the locomotion, and we have and this is the entry state, of course, of the state machine, and then we have the land, which basically blends with another animation, and I don't exactly understand, like, because I didn't went that far in the template, but basically you also have the loop, like the jump loop. That's when you jump, you have the jump here, that is the original jump, okay, going from the ground to the sky. Here it's to falling, sorry, here if we follow the direction of the arrow, falling, which is basically like hanging in the air, okay. And this is a direct connection without any condition. Why? Because we don't have any condition from going to this animation to this one. We just want this to finish before transitioning to this one, and that's why we have to check the automatic rule based on sequence, which is the condition to say, like, go directly after you finish playing this animation to the other one. Okay. And here the jump from to falling, here we're checking, are we falling, and is the velocity on the vertical axis greater than 100, then we can go to the jump state, okay, which makes sense. And this to falling is just, if I recall correctly, basically those are to avoid having too much transitions, like states connected together, and like avoiding mess. Those are aliases, a little bit like reroute that you have in blueprints, but that's maybe too much into details. So if we come back, we have the main state machine there, and we are also playing like the default state. I will avoid explaining that because it's related probably to not probably, but to animation montages, and I don't want to explain in this video what it is right now. Maybe one day I will do a dedicated topic regarding animation. And here we have control rig. So control rig is procedural animation made on top of that. Basically, this whole logic is to place the foot on the ground automatically after the animation has been played. So you can imagine this as a sort of a final tweak processing done automatically. So when you look at the character, for instance, near the ground like this, you see I'm gonna eject my controller from the character so I can move with F8. You can see how the foot is put on the ground, and this is done by recasting and lots of different things. Okay, so that's the animation state machine in a nutshell, I must say. The whole thing being, to understand, being that the event graph is actually grabbing the data from the movement component to know if we should trigger some animation state or not. Okay. So now I think it's a good time to start implementing a new feature in the template. So what we are going to do is introduce new classes in order to create this gameplay feature. So the first thing I want to do before that is actually I want to implement a cursor in the center of the screen. So we are going to discover a little bit how UI works in the engine. So when we start a project, as you can see, we don't have any UI on top of the screen in the viewport, and that's our first goal. So if we go in the contents third person blueprints, we can right click and add a user interface widget blueprint type. So you can see here it's of type user widget. So we're going to derive this blueprint from that, and we are going to call it simply HUD, okay, head up display, which is some familiar term in the game programming field. When we double click, you can see we have an interface similar to standard blueprints that we've seen before, but because it's a of type user widget, we have different components that we can add and a hierarchy that is meant to receive UI elements. So the first element that we're going to add is the canvas panel, which will basically describe the area of the screen. As you can see, it fills up all the space that we have, and it's usually a good idea to have this as a parent. In the previous Unreal version, Unreal 4, we had that by default, but now in 5 we have to introduce it ourselves. So it's a good way to organize and to parent all your widgets on top, to this. So now you can see we have different objects such as checkboxes, text, sliders, and things like that, but what we want is an image, and we're gonna very quickly build up a crosshair using two boxes, two rectangles. As you can see, when I place an object, we have this sort of flower that exists, and this flower is what we call an anchor, and anchor is basically a guide for the components to follow. So you can see that the center is there, therefore when I'm gonna rescale the screen, you can see how it's rescaling based on the location of this flower. If I put it there, you can see how it tries to maintain the distance or a sort of proportionality between the center of the flower and the component. Okay, so what I want is I want to make the anchor in the center. So when I select the image there, I can click on this button to center it, and I can also say, you know what, based on this center or on this anchor, I can reset the position. So when I put 0, 0, you can see how the top left corner snaps to the center of the flower. I also want to make it maybe a bit shorter on the x-axis, and maybe, of course, less thick. So 50 and 5 will be good. And I also want to change the alignment there to be taking 50% of the width and 50% of the height. So it's totally centered around the flower. Okay. Now I'm going to duplicate this element by pressing Ctrl D, resetting the position, and instead of like 50 and 5, I'm going to do 5 and 50, and therefore I have a sort of crosshair, like default crosshair like this. So if I compile, I started the game, but there is of course nothing, and this makes total sense because we didn't created an instance of this blueprint, and on top of that we didn't add it to the viewport. So let's do that. I think I'm going to put that in the game mode, but usually what we do is we put that in a player controller, because the UI is something related to the player. Okay, so that's very common to see UI implemented there, or at least created, instantiated there, and added to the viewport there. But because we don't have a player controller accessible right now, I'm going to do it in the game mode. So the first thing to do is in Begin Play, I'm going to create a widget of type BP_HUD. And you know what? Usually it's best to differentiate in the namings standard blueprints and widget blueprints. So I'm going to put a W in front, so WBP for widget blueprint. And as you can see, of course, it asks what player is going to be owning this widget. As I mentioned, player controllers are usually owning the interface, and this is also due to, from a design point of view, this is also due to the fact that Unreal is a multiplayer engine, multiplayer-oriented engine, in the sense that usually in the context of a multiplayer game, the UI is local to the player controller. Okay, you're local to the player, so you don't have to replicate that. So usually that's why we go in the player controller for spawning the UI. But so here in this context, what I'm going to do is I'm going to say that the owning player is going to be the first player controller that we're going to get. And in order to do that, I'm going to get player controller, and the index 0 is the first player controller that exists. And because we have only one, because we're developing a solo game, no worries about the fact that this will be the only one player, okay, controller that spawns, again, if you recall, spawns automatically through the game mode. So now what we can do is we are going to, so this is the UI, but of course this only creates the widget, okay? We didn't add it to the screen, and in order to do that, what we're going to do is say add to viewport, and meaning that we're going to add to the entire screen, as you can see, the widget, and that's it. As easy as it sounds. And now if I play, you can see that I have a crosshair in the middle of my character, but not in the middle of the character, but on top of the screen. Okay, but means that, as you can see, we probably should offset the character and change a little bit some metrics regarding the offset of the camera. So let's do that. I'm gonna go back in the third-person character, and I'm gonna grab the spring arm. I'm gonna put it more or less on the head and grab the camera and offset it a little bit to the side. So if I play, you can see that it looks more like a TPS with interaction possible with the crosshair, and for me at least it looks better. Okay, so that's for the UI. Now what I want to do is I want to start thinking about implementing a feature. So with the feature I want to do is actually I want to show you how to have some objects that we can raycast, that we can hit, using a raycast, or what is called a line trace in Unreal. And basically we're gonna shoot from the position of the camera and the forward direction of the camera a ray, an invisible ray, and if it hits something, it's gonna give us the object that was hit, and then we're gonna use this object to grab it to the distance that we've picked it, and then we're gonna be able to move it, and this is going to be the first gameplay feature that we're gonna introduce. So in order to do that, we're gonna prototype it quickly, and then as we go, you're gonna see that we're gonna refactor, and this is something very common in game development. So you start by showing the feature, and then you clean the feature. Okay, so let's go in the classes, and there is one thing strange, is that I don't see the cube anymore that was in the map. So sometimes it appears. You just have to reload the map and save also things, and now it's back. Okay, so the cube is back. So what I want to do is I first want to make this cube, okay, a reality. So I'm gonna do something very simple. gonna add a new C++ class based on actor. Next, and I'm going to call it pickable actor, something like that, or pickable actor. I'm gonna create the class, and as you can see, it's gonna open directly for me Unreal. And what I want to do is, in this actor, I want to make sure that we're not ticking. Okay, so I'm gonna remove the tick function, and again, the tick is, if you recall, I need to reload, by the way, don't save, okay, something like that. And if you recall correctly, ticking is the update function, so every frame, okay, it's called every frame. We don't want that because we just want a simple actor, so let's remove also the comments. And I also want to disable live coding because I know it's gonna work badly in my context. And remember, like to do that, otherwise you're gonna probably have an error when you're gonna press Ctrl B. Usually live coding, so live coding can work sometimes, but it's the halt reload way of working in Unreal, meaning that it's a sort of fast compilation that works sometimes, but it's not working all the time. So that's why I usually avoid using live coding. Okay, so we have this actor. What I want to do is I want to start adding components to this actor. So the first thing I'm gonna do is adding a private section. Okay, usually I like to put my components there, and I'm gonna add a uStaticMesh component. So uStaticMesh component pointer, of course, and this is going to be called mesh, and I need to forward declare it because I don't want to include the uStaticMesh component file over there, .h over there. So back in the pickable actor, I want to create this object. So what I'm doing is that I'm going to say that my mesh pointer is going to be receiving a new sub-object pointer of type uStaticMesh components, and I'm going to name it mesh. So it's exactly the same thing that we've seen in the character when we were creating a new components. We use the createDefault subobject method, template method, passing as the type the component type, and then we pass a text with the name of the component. Okay, so quite easy. What I want to do is I want to make sure that the root component of my hierarchy is this mesh, and when we build, you're going to see that we'll have a new component if we create an actor based on this class. So what I want to do is I want to right click on the pickable actor class, and I'm going to say create a blueprint class based on pickable actor, which is a shortcut in order to create a blueprint that extends this class. If you want to do it in another way, you can also do it the standard way in the blueprints, right click blueprint class, and here in all classes you should have pickable actor that is valid anymore. So let's do it the other way around because it's unseen like this. So I'm gonna call it BP pickable box in this context, and I'm gonna put it in the third person blueprint folder. And as you can see, by default, because we set the root component to the mesh, we have a static mesh component as this object. But we cannot see the details, and this should ring a bell in the sense that we don't have a U property. So I'm gonna add a U property, okay, of type visible anywhere. I'm gonna say blueprint read write, because I may be able to change the static mesh component in a blueprint and read it, of course. I'm gonna say put the category as a component, and I'm gonna say meta equals allo private access equal true. I think it's something similar like this, if I recall. Usually it's something that I'm constantly having a reference to. Yes, I need to put, as you see, I need to put this in parentheses, in quotes. And now if I build, I should be able to see the details of my mesh. So if I come back, I have the mesh, the details, sorry. So I can set the cube, so It's the chamfered cube that I'm going to use. Okay, and I'm going to compile and come back there and remove this cube now because I want to use the pickable cube. Okay, pressing the N key I can put more of them on the ground. Okay. So sorry, pressing the N key I can snap them on the ground, and I can press the Alt key in order to duplicate. Yes. Okay, so now what I want to do is I want in my character to have a new component that is not going to be a scene component, therefore it's not going to be part of the visible objects and having a transform and things like that. I want to have a component that is made for logic, and this is something I'm going to call a grabber, which is an object, a component that's going to like do the logic of grabbing some objects. Okay. So in order to do that, I'm going to create a new component. Okay, so sometimes it's good to press Ctrl-Shift-S to save everything, just in case the engine crashes. And then I'm going to go in the classes, and I'm creating a new class deriving from actor component, because we want to create a component for our actor. I'm going to call it the grabber, and I'm going to create this class. Okay, so I can remove the tick because I don't need it. If I need it later on, I'm going to reintroduce it. Okay, let's say you cannot tick for now. Just removing the components, not saving that. Let's come back with the grabber. Removing the tick components. Okay, so the thing I want to put in the public functions is a start grab function and a stop grab function. Okay, so I'm just gonna close all the classes because sometimes it helps Visual Assist loading the classes, which is apparently not the case now. Takes sometimes all the time with Visual Assist to parse the new classes. Okay, we're good to go. So here, because I've created two prototypes there, I can press Alt-Shift-Q on top of the uGrabber class, and I can create the methods that are missing in the C++ file, so it's going to automatically for me create the implementation. And now I have stop drag and start drag over there. So usually what I like to do still is to grab the begin play and put it on top. Something like that will be much better. Okay, so the thing is that I would love to get reference to, so in start grab, what we want to do is to start grabbing. So it means that my idea is that when I click, I shoot a ray from the camera in a direction of the camera, and I want to test if there is an object intersecting it, especially a pickable actor. So what the way I'm going to do that is by first implementing the input action, and then we're going to see how to implement it. So here I want to add a message on screen in the start grab. I'm going to say start drag, and in the stop grab I'm going to duplicate this line. In the stop drag I'm going to say stop drag, so we just have some feedbacks regarding the grabber. So if I come back to the character class here, what I want to do is I want to create a new component that will be of type uGrabber. Remember that when you create a new class in Unreal, when it's a uActor component, it starts with u and it adds in front of your class name the u. So this is the convention. And if we come back to the character over there, I want to add a new grabber, and I will call it grabber. I'm going to just copy using Ctrl-D, and Alt up and down can help you move the lines, and I'm just going to copy the U property, and here I'm going to call it grabber or gameplay. It's going to be a new category. And the grabber I'm gonna construct it very easily. So a little bit higher, like this. I'm gonna say grabber is, I'm going to create a default sub-object, and I can do that because a grabber is of type uActor component. I'm gonna press Alt-Shift-S to include the grabber.h file, and I'm gonna say, okay, it's called grabber. As easy as it sounds. I'm gonna build, and we should see in the character class a grabber component that appears. If it doesn't crash. Sometimes it crashes with components, as I mentioned. So let's move a little bit further before recompiling everything. So one other thing that I'm sure I want to do is to have something similar than the jump action, but for the grab, actually, for the left click. So I'm going to copy this block offline, and I'm going to say now it's called grabber action or grab action, something like that. I also want to bind this action, so I'm going to duplicate one bind action in the setup layer, and I'm going to say it's the grab action that we want to bind. And as you can see, I need also functions. So the functions that I'm gonna need are on the grabber. So here this time it's not on this object, it's on the grabber object. Okay, and here we need to make sure before binding those inputs that the grabber was actually created. So it's a pointer, so make sure that it's possible. So I'm gonna go with the grabber, and I'm gonna say uGrabber, and I'm gonna say start grab. Okay, actually I'm wondering, because you know that it receives an action f input action value, and I'm not sure if we want to do that here actually. So I think it's still better to have a method on this class. I'm thinking out loud here, so I'm gonna still have here a class method, sorry, start drag. So here in protected I'm gonna have start drag. I know I'm gonna have stop drag also, so or start grab, sorry, and stop grab. And I'm gonna also implement using the value. Oh no, sorry, I'm doing a mistake, huge mistake. I can, because it's a trigger, so I'm not going to it's a trigger action, so I can come back. I'm not going to receive anything. I'm sorry, it was my mistake. So let's move back on this idea of binding directly to the grabber. So if the grabber exists, we bind the grabber, and we also, so it's on the grabber pointer, and it's uGrabber, and the method is start grab, and I can duplicate this line, and now it's when it's completed, meaning that when we release the mouse click, we'll have stop grab. Okay, so this will work actually. So that's quite neat. And okay, let's build and run the engine using Ctrl F5. So just in case here, before we were binding some functions that were on the object, now this time on the grabber. And so you can see I've made a pretty important mistake, because here it's not grabber, it's grabber action, of course, that we want to bind. So let's build again, should work. And we can press Ctrl F5 and it will run the editor. Okay. So what we have done there is we created a new input action. At least we a pointer to a new input action. We bound the input to directly the functions in the grabber, and we hope to have some message on screen when we will press the inputs. So let's go in third person in the input there, in the action. I'm gonna duplicate by pressing Ctrl D an action. I'm gonna call it grab. I'm going to save everything, come back. In the mapping context, I'm going to map a new action of type grab. I'm going to click this keyboard and press just to have the left mouse button. I'm going to save everything, and coming back in the third person blueprint BP character, I'm going to add, opening the full blueprint, I'm going to add the new input. And by the way, you see we have our grabber component there, and here the grab action will be grab. Okay, so I compile and I test, and when I click, you can see I start drag, and when I release, I stop drag. Okay, so it's a press event in the sense that it's triggering all the time the start drag unless I release. Okay. So if we come back there in the grabber, okay, the thing I want to do is I want to add a boolean that will be, let's make it private. And usually we start boolean by the letter B lowercase, and what I want to do is has start drag verb, something like that. It's going to be false by default, and as soon as we start, we say yes, we start the grab. Here the start grab is false because we released, but before, if B has start grab, meaning that we are starting to grab, I'm going to return because I don't want to execute the content of this function. Okay. So what it does is when I build, you will see that I will only have one log when I start dragging. So basically removing the continuous press functionality. So I press, I release, stop, drag, start, drop, start, stop, etc. Okay. So pretty good news. So now in the start grab, the whole idea is that we'll need to send a raycast. In order to send a raycast, what we do is we need to have first the start and the end of this ray, okay? So of this line, of this invisible line. So the start location is going to be, of course, f vector. So vector, and remember that f is usually what prefixes the struct in Unreal. So this is going to be the start location, okay? And we are going to have the end location of the vector. Okay. So for the start location, what I want to do is I want to get the camera of the player. So to do that, I will need to grab first the pawn. Okay, and we are in a situation where the grabber is inside the hierarchy of a pawn. Okay, so there is a concept in Unreal called the outer object, and the outer object is the object that is outside of this object, and in this context it's a pawn, which is the character, okay, the Sociomix intro character. So what I want to do is directly in the constructor, I want to keep a reference, let's say a private one, to the pawn. Okay. So I'm gonna create a pawn pointer, okay, and this pawn here in the constructor, I'm gonna make it as, I'm gonna get the outer object, and you're gonna see it's a U object, okay, because it's the top object of the class hierarchy in Unreal, but I'm gonna cast it to a pawn, okay, and no need to say pointer because it's gonna cast automatically to a pointer. The cast function is actually getting an object and trying to convert it to another type. Okay, this can cost a little bit, and this is why I'm doing that in the constructor once. Okay, so now that I have the pawn, what I can do is I can, just to prove to you that this works, what I can do is I can log it. Okay, and I'm gonna log it and say outer is, and I'm gonna put the name of the pawn, so pawn dot get name, and remember to dereference the strings because we need a C type string. Okay, and if of course the pawn exists, I'm going to log that. So when I'm going to build, because it's in the constructor, it's even going to be logged in the editor, so you're going to see it directly, and it should be able to grab the outer object, which should be cast to a pawn. And you can see here, outer is default Sociomix intro character. So apparently it has been done multiple times, which is quite weird. So let me recompile just once to retrigger the things, and you can see it's retriggering it once, and it's the default Sociomix intro character. Okay. And of course, when I run the game, you're gonna see outer is the BP character that is instantiated actually by the game mode. Okay, which is great. Okay, so now that we have the pawn, what we can do is here in the start grab, we can first directly go out of this function if the pawn is null. So if the pawn is null, we return. Okay. So we don't go, we don't pursue the function. And here, as a safeguard, we're gonna do if it's false, there is no need to go in this function. And of course, if the pawn is also null, we should return because we're probably gonna use the pawn. Okay. One other thing I want to do is I want to get the controller from the pawn. So here, what I'm gonna do is reference a player controller, okay, which I'm gonna call PC. That's usually what we do when we are getting player controllers. So remember, a pawn is possessed by a player controller. A player controller is sort of the brain of the object. And here what I'm gonna do is I'm gonna say from the pawn I'm gonna get the controller. But as you can see, it returns a controller and not the I can say it, and not the player controller. And I don't think there is a template, or at least I'm rarely using it. If it's the case, usually I cast, and if I get controller, apparently there is a typed, yes, apparently there is a typed object, as you can see. So it seems to work. Okay, so if I build, here everything should be fine. Okay, and now here I should have a player controller. If of course I don't have a player controller, if it's no, I return. No need to pursue. No need to continue. So now what I want to do is to get the camera location, and I have, as I mentioned, the start location, and I also want the rotation of the camera. So I'm going to also have a rotation which will be camera rotation. Okay, and in the player controller there is a class called player camera manager, and the camera manager is, as the command says, associated with the player controller. So this is something quite neat because it has the camera information, and we can say, for instance, here, let's get the camera viewpoint. And here we have two variables as argument, as references that we can pass, the location that will be filled by this function, and the camera rotation that will be also filled by this function. So I'm going to put start location and also camera rotation. And you know what? Because it's easier to understand, I'm going to call it camera location instead of start location, even though we are going to use that as, of course, the start location of our raycast. So this should have filled those two values. And just to prove that it works, we're going to draw debug a sphere. And as you can see, the first thing is getting the world. The world in Unreal Engine is an object that contains all the actors in the game. So it's sort of a top object that is a sort of container for all the actors, and we are often asked to reference it, especially when we want to deal with functions that are linked that are linked to the notion of having of the world. Okay, if you want to do that, you can use the getWorld function. It's always a good practice to make sure that the world exists, but here I'm pretty sure that it will exist, so I'm going to avoid this the safety check, but please in production code make sure you do that, because it returns a pointer. The second thing in this draw debug sphere function is to put the center of the sphere, so we're going to put camera location. The radius, let's put 20, and the segments, let's put 12, and the color, I'm going to use a constant in the struct color called red, like this, and I'm going to say yes, it's persistent, so I want the debug object to stay forever. And I'm going to build, and you're going to see that when I click, I should be able to get the player's location for the camera. So when I click, a sphere appears at the location of the camera. Okay, so that's why we can see it. Okay, so that's quite neat. We know it works. So great. Now what I want is the direction of the camera. Okay, so in order to get the direction of the camera, we also have the rotation. And if you recall, back then we used a transformation expression in order to get from a rotation matrix the axis that was the x, and if you recall correctly, I mentioned that x was the forward axis in Unreal. Okay, so the way we've done that is, let's say camera forward, we can create a f rotation matrix passing the rotation that we want to convert as a matrix, and in the matrix we have get unit axis, which is a function that takes into account which axis do we want to get. And in this context I want to get the x-axis. And the great thing is that I can also add I can get the forward vector of the rotation. There is also, just to show you, a simpler method which is like this, f vector, so forward, is I can get the camera rotation and I can get directly vector. And vector is always going to give the forward direction of a rotation, okay, of a f rotator. But if you want to change and to get the right vector or to get the up vector, you can do that with the line above and like having going through a rotation matrix. So this is simpler, but only gives you access to the forward vector. So I'm gonna still keep the longer version, which is you should be familiar with. Okay. It's going to be a unit vector, meaning that the length is going to be 1, of course. So now what we can do is we can draw, we can get the end location. And so the end location of our line will be, and it's going to be quite easy, it's going to be the camera location plus, okay, camera forward times a value. So let's put 100 in this context. So this is going to be, we start at the camera location, we move towards the forward direction of the camera for 1000 units. Okay. So now we can draw debug this time a line. Okay, and I need again to get the world, and I need to get the start of my vector, which is going to be camera location, and then I need to have end location, and then I need to have a color, so let's put it green, and then should it be persistence? Yes, for us, because we want the line to stay so we'll be able to see it. I build, I start, and when I click and I move, you can see that we have indeed a line that was going into the direction of, or at least that should go in the direction of the object, which apparently it's not working. So that's great, we have an issue. That's not great, but at least we have a bug. So let's try to analyze why it's not working. So, okay, this outputs the camera rotation. Okay, and it's super easy to fix. I need to first, of course, send the information before actually using the values that are, of course, at this stage should be valid. So Let's rebuild. I'm pretty sure you've seen the mistakes since a long time. It's the joy of doing tutorials. Sometimes you talk too much and you don't look at silly mistakes. And now you can see that we have lines that are shooting in the right direction of the camera, which is super neat. Okay, I'm just going to remove now the debugs for now at least, and we are going to continue, because now what I want to do is to trace in the world an invisible ray that should hit something. So let's do that using the get world, because world again is where we trace things in the world actually. So we are going to query this line by saying line trace by, so line trace single, because we don't want multiple objects to be taken into account. We just want one object, so single. And now we're going to say by channel, because we are going to, so channels in the physics engines are a way to categorize objects and filter some objects. And what we want to do is to have our own channel where we're going to put all the objects that are pickable. Okay, and we're going to see how it's done in the engine. But basically the idea is that I want to trace by a channel. Okay, so I want to make sure that I have a hit result object that I'm going to call hit. And as you can see, by this function, when we hit something, the first argument is a struct out it, and it's going to be filled by the function if we hit something. So in this it result object, we're going to have lots of information regarding the object that we've hit. Then the start, it's going to be camera location. Then the end is going to be end location. Then the trace channel now, and we have multiple channels as you can see. So we have world dynamic, world static, so static objects, dynamic objects, vehicles, spawn, what type of objects that we want to hit. So you can see that by default we already have like common ones. But in the end, what I want to do is I want to have my own channel, okay? And I'm going to use the first slot, which is game trace channel 1, okay? And you're gonna see that, okay, game trace channel 1, sorry, you're gonna see that we will have to set up it in the engine. And I'm gonna re-explain everything, no worries. And then the rest we can leave it at as default, as it's gonna work. So now basically this line asks the world to send a ray starting from camera location to end location, trying to hit only objects that are in the channel game trace channel 1. Okay. If it works, it's going to return a boolean true, a true boolean, and here we've hit something. Okay, so let's, just for fun, we're gonna grab the actor that we've hit. So we can say hit.getActor, because at this point we know that hit is going to be filled with the actor and the information. And we're going to say get location, get actor location. So we're going to grab the location of this actor in a vector location, actor location. And what I want to do is to again get the actor, and I want to set the actor location, and I'm going to use a new f vector, and I'm only going to change, so I'm going to get the actor location plus adding 100 in the z-axis, meaning I want to teleport the cube, or the object, sorry, 100 centimeters above. Okay, so let's do that just for fun, and this should give us some information about the object. So I'm going to build. You're going to see that it's not going to work, of course, because we don't have this channel being set up. So in order to set up a channel, we need to go into project settings. So edit project settings if you don't have this window open. And you can go in the collision, and here you have trace channel. And you have up to 18 custom channels. Okay, so let's create a new one that we're going to call pickable, for instance. And by default, it's going to be set to ignore, in the sense that we don't want this to be responding to anything, because if we don't do that, you're going to see that all objects are going to be using the default response of this trace channel. So I'm going to say accept, I'm going to call it pickable, and you're gonna see, sorry, that for instance in the let's take the character, the mesh, here in the collision, you see that we have a preset, okay? But if we see it's not accessible because it's not custom, but you can see that pickable by default is going to be ignored. So it means that when we are going to trace in the world or collision in the world, do collision detection, this pickable this object is not going to be, if you want, in the trace channel 1, okay, called pickable. So if we come back to our object, so the box, by the way, a nice shortcut is that you can select the object and press Ctrl E to edit the blueprint. So I edit the blueprint of this object, and now here, just for this object, because it's specific, in the mesh, here in the collision, where it is, first I want to simulate the physics of this object, because I want the object to fall, enabling gravity also, and I want here in the collision to say, I'm gonna have a custom preset, but this time the pickable is going to be block. Okay, so I'm going to be blocking intersection with the traces that are pickable, okay, or even with the collisions, but for now we're talking about trace. So I'm gonna compile everything. I'm gonna press Ctrl-Shift-S as a good habit in order to save everything just in case it crashes. And just to note something is that here we said EC game trace channel, okay? But in fact, this is related to the pickable trace channel. It's a good practice to usually define a macro. Like we can say, for instance, here, hashtag define ECC underscore pickable, like this. This will be replaced basically, so it's easier to read, okay? But in the end, we're using still the game trace channel 1. And one thing to note is that in the config file, in the default game INI, if I open the block node, it's not default game, sorry, it's default editor, maybe, or default engine. Am I wrong or am I right? We're gonna see that. Yes, you're gonna see here that we have a game trace channel 1 called pickable, okay? But it's still referenced in the source code as ECC underscore game trace channel 1, okay? I know it's a bit weird, it's not very easy, but that's the way it works. So that's why usually in code you redefine another name like this. And again, a define macro is just a copy paste, so it's going to, each time it reads that in the compilation, it replaces it with this. So here, literally in the source code, it's going to be ECC underscore game trace channel 1 before compilation. Okay, great. So now if I build, because I've set the right, okay, I crashed, so I restart the editor, but because I've set the right trace channel on the cube, I should be able to pick only those objects, okay? So let's try. I'm gonna play. Nothing works, but for those objects. You can see how when I pick them, they're just going to go up by 100 centimeters. Okay? So great. We have a sort of the start of something. We have the grabber that's more and more coming to life. So let's comment that. And the next thing now that I want to do is I want to, again, try to think about what am I going to design, what I'm trying to design. I'm trying to design a tool that when, a feature that when I pick an object, it follows the anchor point of where I picked, and when I move, it goes along with my character, okay? So, by chance, is there anything working like this in Unreal? And the answer is yes. In Unreal, you have something called a physics handle, which is a component that helps you grab physical objects, okay? So we are going to go in the character there, and we're going to add a new component of type uPhysicsHandle component. I'm forward declaring it, as you can see, and I'm going to call it physicsHandle. and I'm gonna also duplicate the property on top of it, the U property. Here, before the grabber, I'm going to actually create a default sub-object of type uPhysical_handle component, and I'm going to put this text, and it's physics_handle_comp like this. And I need to include, of course, Alt-Shift-Q. We're using Visual Assist, the physics_handle_component.h, which is in PhysicsEngine. Okay. So now I have a physics_handle component, which is not a scene component. It's an actor component, so it doesn't have any transform. And what I want to do now is I want the grabber to be able to access this component. So in my grabber class, I'm going to have a public function, say let's call it set physics handle. It's going to grab a uPhysics handle component called physics_handle_comp. I'm going to for declare it in my prototype, and I'm going to press Alt-Shift-Q and create the implementation for it. And here I'm going to press Alt-Shift-Q again and include the physics_handle component because it's very important for me to do that in this class. And I'm going to have as a private reference a U that I need to for declare, a uPhysics_handle component called physics_handle like this. Okay, so now when I will be setting the physics_handle component, the idea is that I'm just setting the physics_handle comp like this, okay? Nothing more, nothing less, it's just a simple setter. If I go back in the character, I can, because I created the handle before, after the grabber, what I can do is I can say set physics_handle and I can pass the physics_handle, which makes sense. So now the grabber has the consciousness of the physics_handle component that was created on the character. So if I build everything, it may crash because I'm adding new components. Actually, it works. So if I go in the blueprints and I open the third-person character and I reopen, you're going to see that I have a physics_handle here and I have a grabber also, and the grabber internally knows about the physics_handle. Okay, great. So the cool thing is that now in the grabber here, I can grab the object. So I can use the physics_handle object. If the physics_handle is null, by the way, we return, no need to pursue. We need the physics_handle to start grabbing the object. And we're gonna say grab component at location. And the component is going to be the one that we've hit. So it's going to be hit.component. That's get component, sorry. So that's super cool because it's already in the hit result giving us the uPrimitive component, and this is exactly what we want in the handle, in the physics_handle grab components application function. And the bone name that we want is going to be name underscore none, like this, with capital O-N-E, which is a constant existing in Unreal. That's actually like saying we don't want to attach it to any bones because we're not in the context of like a skeletal character. And the location where we've picked it is in the hit location. So it's the hit point in world space where we've where we've intersected the object. Okay, so okay, the object has been grabbed. Okay, but we need now a way to make it move actually and follow, because if I compile and I play, you're gonna see that actually nothing's happens. It's because the object is ready to be grabbed, but we don't update the target location of the grab. Okay, so that's what we're going to do next. And in order to do that, what I want to do is I want to reintroduce the tick component function. So I'm going to press Alt-Shift-Q on the uGrabber with Visual Assist. I'm going to implement a virtual method, and this virtual method is going to be called tick component. Let's do that. So now you have tick component. And one thing that's quite important is that the can ever tick is back to true. Okay? Because we want to make sure we are ticking. Okay? So here in tick, let's make sure that we have a message on screen saying tick component or grabber tick to make sure that we can actually tick this component. So I'm going to compile. Go back to Unreal, and you can see it's not working. So this is exactly what I thought it was doing. So sorry, it's in the character there. And here we can see, so start with tick enabled. Should be actually ticking, and let's filter tick, allow tick. Okay, it should be ticking actually. So we have sort of an issue. Okay, let me check what is doing wrong. Oh, quite easy. I'm not calling the parent method. So remember to always call the super method. Okay, using the argument that we pass this function, this tick function, like this. And remember, super is going to be the parent actor. So in this context, you can even see it with Visual Assist. It's uActor component. Okay, and we need, of course, to tick to tick till the to use the tick of the actor. So now it's going to work when I compile. Pretty sure. Oh, still not working. What happens? We're ticking. We built. It's quite strange that it's actually not working. Let me restart the engine. After restarting the engine, it works. So sometimes when you have issues like this, make sure you restart the engine when you're pretty sure that it should work actually. Okay, great. So we have like a tick function. What I want to do is to make sure that I was grabbing something. So I'm going to add another boolean that says b has grabbed. It's going to be false. So here it's going to be true, of course. And here in the stop grab, I'm going to say has grab is called false, of course, also. And I'm going to say physics handle, of course, when I stop dragging and I want to release the component that I'm dragging. So there's a release component function. So I'm going to start like this. I'm going to build. And now I just have a boolean that when I'm grabbing, I'm sure that I have grabbed something. So meaning that in the tick component here, what I can do is make sure that if I'm grabbing something, what can I do is I can get the physics handle and make sure also that the physics handle is true. Okay, and now I can set the location, the target location, and I'm going to set it to a new location, that is the target location. And target location will have to do something very similar than what we've done here, is actually grabbing the pawn and computing probably this. So let's come back here. Let's copy and paste this. Before the tick, I want to make sure that we should have the pawn, the physics handle, and we are grabbing. So maybe, you know what, I'm gonna even do something simpler. I'm gonna say return, follow the same convention. If we are not grabbing, we return like this. And so we're getting back the player controller, and what we do is if the player controller is not, we return, and we should cache this as a variable. That should be more proper. And what we do is we grab the viewpoints, the camera and the rotation. We compute again the forward of the camera. The end location is like this, but for now, if we grab the object, it's going to be directly at the end of the ray trace, so quite far away. But for now, it's going to be okay. But because you're going to see that it works. So if I do that, instead I put end location over there, you're going to see that it should work actually. But it's not going to be a proper behavior, as you will see. So if I grab the object, it's pushed far away, but now I can grab the object and move along with it. Okay, and if I release, the object is being released. Okay, but what I want is that if I'm closer to the object, I want to grab the object, but maintaining the distance between the camera position and the object hit point, okay, the raycast hit point. Now it's pushing it to 1000 because that's exactly what we've written over there. So what we want to do is when we hit, we want to store the distance of the hit point, like the distance from the camera to the hit point, and we're going to call that hit distance. And the hit distance, we can compute it when we start to grab here, and we can say, okay, the hit distance is equal to hit.distance. So the result, in the result, hit result, we have some information about the hit distance. And we can say here, instead of 1000, we put the correct hit distance. So I build. It compiles. And if I come back to, oh, it crashes, of course, why not? I can restart the engine. And now I should be able, if I play, to grab the object at the distance where I'm picking it. So if I'm close, you can see that I'm picking the object from close, from a close distance. And of course, the 100,000 distance ray is the distance of the raycast. So if I'm far away, you see I cannot pick, and once I'm close enough to the object, I can pick it, okay, which makes sense. And this is a variable that you can actually expose. So in the start grab over there, the maximum distance, let's say max hit distance, and this can be protected value, let's say. It's going to be 1000 by default, and it's going to be a U property that is editable anywhere, or edit anywhere. And I'm going to make it blueprint read write, and in the category grabber, and no semicolon at the end of the macro, otherwise you're going to have an error. So I build, and you're going to see that once I pick the grabber component in the details panel, you're going to have the joy of tweaking this value to your liking. So here in the BP third person character, if I open it, I grab the grabber, and you're going to see like max hit distance. So if I double it or triple it even, if I compile, you're going to see that I can pick objects from far away now, but not from very, oh yes, from very far away. Can I grab the other one? Yeah, I can grab the other one. So it's very far, as you can see. So maybe it's too far, so let's come back in the grabber and let's say 800, a bit less than what we had before. So you can see we cannot grab it, even there. Okay, we have to be close to it in order to bring it to another location. And this is all for you to tweak in terms of design. So you can see how the objects are hanging in terms of rotation. If we don't want this object to be hanging like this, what we can do is, instead of grabbing the object at location like this, what we can do is physics handle the component. So grab component at location with rotation. So we can say that we get the component of the hit. Same thing, no name, for no, we don't attach it to a bone. We say the hit location is this, and we can also say that the rotation isn't going to change, so we can grab the hit.getActor.getRotation, get actor rotation. So we are basically not changing the rotation of the object. Therefore, the object is not going to hang like this. So if I come back and I test after compiling, you're going to see that I grab the object, but the rotation is unchanging, which is quite neat, because now I can do super cool things such as stacking boxes, which is quite working well, as you can see. So okay, we have a pretty cool mechanic. What I want to do now is to enhance it a little bit, adding what we like to call feedback in the video game industry, and I want to show you a little bit more how to learn like new features of the engine, and basically to add feedbacks. So for the first feedback I want to add is to the BP pickable box is I want to change its material when we are picking the object. Okay, so to do that, what I want is I want to make sure that we're using good programming practices, and we're going to use what we call an interface, which basically is a sort of contract between the classes that implements this interface, in the sense that it should have some methods, some functionalities on it that trust us will be defined. Okay, so we're going to see how it works by first going in the classes and creating a new class of type interface, Unreal and interface, and I'm going to call this interface pickable interface, and I'm going to create the class. So as you will see, Unreal is generating two classes for us actually. The first one is called iPickable interface. This is where we're going to put the functionalities that we need for this interface, and we have on the other side, if we come back there, and we have on the other side in the .h a U interface, and this shouldn't be modified. This is for internal work for Unreal, because languages, for instance, such as Java or C# are using interface by default in the language, but C++ it's not the case. So Unreal Engine has sort of a way of working, of mimicking, if you want, this concept for us, and therefore it generates two classes behind. Okay, so what we need to do here is in the public section, what we need to do is we need to say we can have onStart drag, or just start grab, sorry, or start start pick, or start grab. Let's be consistent with the rest, and stop grab. Okay, and I don't think we have to fill the body of those interface on the other side. Let me check. I don't think we have to do that in interfaces. Yes, it builds. So the engine has crashed, by the way, but we probably we don't need to do that. So now what I can do is I can go in the pickable actor, and I can say, okay, you also implement iPickable interface. Okay, and you will see that here what we can do is to re-implement those functions, because here we found an interface and we are expecting those functions to be valid. So we are going to implement the functions, not the virtual functions actually, but the real functions. So void start grab and void stop grab. And if we build, it's still not working. And okay, of course I need to say also it's public before, and if we go look at the error, iPickable interface base class is undefined. Of course I need to include the interface pickable. and so that will be another step, and it should actually work like this. Let me go to the grab functionality. So start grab, okay, I'm gonna implement start and stop grab, so create method implementation, going in the CPP. Here I'm gonna say print a message to the screen, and I'm gonna say it's cyan. Now it's start drag from pickable and stop drag from pickable. Okay, so we want to see those screens, those print on screen. So I'm gonna save everything and go back to the grabber, and I'm going to check here if the object is actually implementing the interface. So the way it works is we can do a cast to pickable interface, and we can make sure that this is the hit actor, hit.getActor, like this, and we can say we can grab a pointer of this, so let's call it interface. Let's make sure we have the include for this interface, and let's put everything inside there. And if we debug the message screen, we can say interface just to make sure that everything is working. So I'm going to build everything, and if I come back to the editor, when I pick, you can see it's actually casting correctly because the A actor is implementing the interface over there as a public interface. Okay, so now what we want to do is to call those start grab methods. So in order to do that, we are going to go in the grabber again, and we're gonna say the interface, we're gonna call execute start grab, and the underscore execute is actually something related to the functions and how we're gonna mark them. So we're gonna come back to the public interface there, and this this event, we are going to mark it as, or not this event, but this method, sorry, we're gonna mark it using u function. So we've seen u properties, now we're gonna see u function, and this is going to be I think right now we're just going to mark it as a u function like this. We may change that in a bit. And the start grab, we're doing the same. We're gonna play around with the stop later on, but okay. Interface functions that are not blueprints implementable events must be declared as virtual. Okay, so this should be a blueprint in the interface. Still, this should be a blueprint implementable event, and also should be blueprint callable. Okay, let's not put any for now. At least let's not put any categories for now, and let's try. This is going to say that must be declared. Not like that, but must be, for instance, let's say make it blueprint callable, and also make it a blueprint native event. And with native event, as you're gonna see, we should, instead of having the name of the function like this, we should, and this is the engine that decides that, we should put underscore implementation instead of the real name, because behind the scene it's going to generate some files that in the end is going to call the method in C++ implementation. So let me try to build this time. still have an issue. Execute start grab isn't working apparently. So, oh, and apparently the error is function does not take 0 arguments. Okay, so apparently we need to pass an object that is a uPointer object. And if we look at the grabber here, we probably should pass, let's pass the, I think we should pass the actor that is therefore owning the function. So it should work like this. So I know it's a bit convoluted, but behind the scenes it generates, and I don't know where, but we can probably find it in the generate file. So we cannot find it, but basically we need to pass a u object to this function. So I'm going to test and re-explain everything. So you can see that we have the start drag from Pickable. Okay. So let's try to now understand again. Once back, we're going to re-explain everything. So the Pickable interface, here we mark the functions, we declare the functions. It's a sort of contract. We say, here are some functionalities that we are actually expecting from the objects that are implementing this interface. I made them blueprint implementable events in the sense that they can be implemented as an event in Blueprint. So you remember the red boxes that we have in Blueprint. So if I go here, I double click in the Pickable box, you will be able to see that we should have start grab, which is an event. Okay, from so this is a function actually, but we should have start grab event like this. And this is because in the Pickable interface, and therefore here in the actor, if we go there, it's blueprint callable, so we can call it if we want to execute the event in Blueprint. And it's a native event, meaning that Blueprint native event tags are callable in C++ through the underscore implementation method over there. So we can put our own C++ logic there. And they are also callable in being called in Blueprints. Okay. So then if we come back to the grabber there, we cast to the interface to make sure that this object can cast to the interface. That again should be the case because thanks to multiple inheritance, we are also deriving from iPickable interface over there. And because of the Unreal magic behind the scene, it's generating a function called execute underscore plus the name of the function, and then passing a u object that is probably a context object, but in this specific case we don't care about the object that we're passing, but the actor is actually a good one in this specific context. And you can see that it works quite well there. We can do probably we can stop the actual, we can call the stop function the same way. So what we need to do is in the interface we need to mark the stop grab as a Blueprint implementable function also, and Blueprint callable. In the actor we should do the same thing there. Oops, sorry. And remember to mark it as underscore implementation, which is the thing that can be missed often. And then in the grabber there, what we want to do is actually we're going to store the actor interface or last object picked. We're going to store that in a member, so it's a pickable interface pointer. Okay, something like that. And here we're still going to execute start grab, and here if this is false, we return also. But but before doing that, we are going to execute stop drag passing what can we pass there, because we don't have the it actor. Let's pass the physic_handle.get component, get grabbed component, which is a U object also. Let's do that for now, and let's validate that it works. So I'm gonna build everything. I have some issues. Missing a star. Okay, iPickable interface should be should actually be included. And stop grab, sorry, not stop drag, stop grab. And in fact, I can probably declare it instead of include it, which should be much better. And here, let's do this instead, which should be much more readable. And you know what? I'm going to rename this object last pickable interface, which looks a bit more like what it is, and I'm going to rename it. Let's build. Takes a little bit more time this time. It works. And if I'm going to remove this event, and if I play start drag, and if I release, oh, huge crash. And the crash comes from pickable interface line 147, and it says get class implements interface. Apparently it's not implementing the interface. Okay, so let's look at this. I don't know why, but maybe it's related to the grabbed object. Let's put this, so the grabber object instead, and let's check that it works. I'm gonna close and restart the editor. It's apparently still crashing, so execute stop drag is not working. So, okay, last pickable interface, execute stop drag. It's probably because it wants to get back the actor. So okay, let's store the interface, and also let's store the last it object, because it apparently inside the execute recheck that it correctly gets the interface, so implements the interface, sorry. So what we need to do is a actor last pickable actor. Let's do that. And here, when we hit something, we're gonna say the last actor is hit.getActor. Something like this, which will be in the end more readable. I can replace it wherever I want. And here, instead, I'm gonna do that last pickable actor, because it should this time implement the interface. So I'm gonna build. Should work still. I can run the editor once more. and we can test, and it should work because it's checking when it executes the function, it's actually checking that the interface is implemented correctly. Okay, so just in case, we may want to make sure that this implements the interface too. So implements the interface too. So to do that, we get the class of this object and we say implement interface, and here we can say what's the name of the interface again? Pickable interface, and we get the static class. And remember that just for this line, we're getting the class of the last pickable actor. So here it should be a pickable actor. We check if it implements the interface, and the interface that we check, where we're getting back the class, so the type definition, okay, not an instance, the type definition. So therefore, that's why we're using static class. It comes from the uPickable interface, which is not this class, it's this one, okay, the one that Unreal asks us not to touch. So if I build again, it should be just a last check, just in case this object isn't implementing the interface in the middle, so this is safer, but as you can see, it works. So the great thing right now is that if we come back with the pickable box, we open the blueprint, as we've seen before, so let me remove everything there. As we've seen before, now what we can do is we can have start grab event, and we also have stop grab event. Okay, if I do this and play, okay, you can see that it doesn't work anymore because we're not from the blueprint calling the parent function, which is the underscore implementation functions, like the related underscore implemented function in C++. To do that, we right click and we say add call to parent function, and if I do that, the blueprint is going to trigger, add call to parent function, the blueprint is going to trigger the parent function. Okay, it's like calling the super function. So if I do that, you can see that now we are back with the functionality, the C++ functionality. But the cool thing is that we also have now blueprint functionalities, and that's where I want to actually change the emissiveness of the materials. So what I propose is that we grab the mesh, we look at the material, which is called MI solid blue, but let's create our own instead of the solid blue. So I'm gonna, in third person, create a new folder calling it materials, and inside I'm going to put a new material that I'm going to call m_pickable. I'm going to double click on it, and I am going to pick a color for the base color of this material. Okay. To do that, it's quite easy. I drag a line and I grab what we call a constant 3 vector. Why 3? Because of red, green, and blue. And if I double click the box there, you can see I'm able to pick back the blue color or turquoise one from the object. I'm going to apply that, and I'm going to Control E on a pickable object, and here I'm going to say m_pickable, okay, which transforms my object with this material, like brings the new material to this object. Okay, and now what I want to do in the pickable material, I want to change what is called the emissive color. Emissive, it's a way to make the object glow. Okay, so what I'm going to do, I'm going to drag a constant 3 vector once more. Okay, and I am going to make it glow like this. Okay, but the thing is that I want to make it glow way more, so I am going to increase here the value to 5, which is going to overcome and like push the emissiveness more than 1, so it's not clamped, it's not between 0 and 1. If I push it even further, you can see how it glows much more. But the thing is that I want to make it glow only, like if I apply the material here, you're gonna see it's glowing, but I want to make it glow only when I'm picking it. So I need a way in the material to select if I want to make it glow or if I want to make it not glow. Basically, if I put a black color in there, as you will see, so let's grab a constant free vector. If I put a black color there, it's not glowing. So I need a way to choose between those two boxes based on if it's glowing or not. So the way we're gonna do it is we're gonna use what is called a linear interpolate node. We can also press the L key if we want to and click to generate this node. And we're gonna put in A the no glow color, in B the glow, and we're gonna put the result in the emissive. And the thing is that this alpha parameter, when I put it at 0, it's gonna take the value A. When I put it at 1, it's going to take the value B, okay, the result of the value B. And if I put it at 0.5, it's gonna mix in between those two. So the more, as you can see, the more I'm going towards 0, the less I'm glowing, okay, as you can see. Let's put it at 0, and the more I'm going towards the value 1, the more I'm glowing. Okay, so I want to drive this parameter. Okay, I want to drive it using what? Using a parameter. Okay, so I'm going to input a scalar parameter, and parameters are accessible from an external viewpoint of this material, and you're gonna see how it works. And I'm gonna call it glow percent. Okay, and by default it's going to not glow, so it's gonna be 0. So that's pretty cool. Now what we can do is in the pickable box over there, in the event graph and in the begin play, we can create an instance, a dynamic material instance, which will basically use the material that we set up, and will generate for us an object that is called a material instance, dynamic instance, that we will be able to change its parameter, okay, its internal parameters, so the box that we here generated. Okay, so if we come back there, what I can do is I can say, okay, that's the pickable material. It returns a value, okay, and we need to, from the mesh, set the dynamic or set material, and we need to set it to this material. So basically we are at begin play, we're setting the material with this material, okay, with the newly created material. So just to prove that it works, if by default we're using another material instead of this blue, we're using, for instance, surface material, you can see that in the world it's like this, okay, but as soon as I play, the material is working, okay. So it's great, but there is also one thing, is that in begin play I want to call the parent function. Remember, it's really important because we have logic in there. That's why I couldn't drag the cube before, so remember to call the function in C++ also, or like the logic in C++. And what I want to do is also, I want to right click on the return value there, and I want to say promote to variable, okay. So this is generating a variable here that I can call pickable mat, and I will set it like this. So first it's going to create a dynamic instance material, then I'm going to set a local variable, and then I can also have an output which is the same thing over there, so it's way easier to read. And then I'm setting it like this, so I have a reference there. The cool thing is that when I start grabbing, what I can do is here I can get a reference to the pickable material, and I can set a scalar parameter. Okay, and what's the name of the scalar parameter? We called it glow%. Okay, so F2, Control C, and I'm putting it there. So when we start grabbing, I'm going to put that to 1. And when we stop, I'm going to put that to 0. If I compile and test, you can see that it works. We illuminate the box, and then when I release, it stops illuminating. Okay, so we understood how to put feedbacks using a material. It's very simple, okay, but it works, and you can understand how the logic works. Okay, so I'm not going to do a full course on materials because it can take days and it's quite intense, but the thing I want to share with you is maybe also after we're gonna discuss about a last feature, which is going to introduce collision detection and also what we call delegate in Unreal, which are very important for programming with events in mind. But before doing that, I want to show you a small trick, which is the construction graph, construction script, sorry, where we can actually put all this logic. So I'm going to destroy the begin play because I want that to be executed in the construction script over there. Okay, and before the construction script, what I want to do is I want to make sure that if the pickable material, I'm going to right click and convert it to a validated get, which makes it's a null check pointer if you want. If it's not valid, I want to create a material and set it. Okay, so construction script, it's like a constructor, meaning that it executes also in the editor. So you can see how now the material is already set up in the editor. Okay, so the construction script, it's where you can in the editor execute some functionalities for your actor by default, and it also triggers in the game when the game starts, so it's easier to see for us because the material is already being set there. And of course, if I change the material to alias reference, for instance, instead, you can see how it changes also at runtime in the editor, and also at runtime as we mentioned. So it was called Pickable. So this is where, for instance, if you want to create some tools in the actors and things like that, you can also write the logic in the construction script. Okay, so I hope it makes sense like this. And now we only have 2 events, quite easy to understand in the event graph for the Pickable box. Okay, so let's talk about, look, let's save everything, Control-Shift-S to make sure we're not losing anything. And let's now create a sort of trigger over there, a trigger actor that will basically be there. And if we put some objects, let's say 2 objects, we are going to increase the count, a counter, okay, of the number of objects. So what I'm going to do is I'm going to create a new blueprint and a new class, okay, first, and this class is going to be inheriting from actor, and I'm going to call it bucket. Okay, so it's going to be a bucket where we're going to put some objects in it. So this bucket we can avoid the object tick. Let's do that. We can remove the tick. can say you cannot tick, like this. And let's compile it again, and we're gonna create, okay, so we're sure it's compiling, and we are going to create some private variables. So one is going to be a uBox component, which is going to be a collision box. I'm going to forward declare it, box collision. And in the constructor, I'm going to place it, box collision is going to create default sub object. Well, default sub object. I'm going to name it box collision, and I'm going to use the template uBox component. And this time control Alt Shift S Q, sorry, Alt Shift Q, and add include box component. So you will see it's in component. It's box component.h. But actually, it should be in components. I think Visual Assist is making a mistake. It's in components, box component. Sometimes you have to be quite picky when it's not working. Okay, also gonna make the root component points to this object, and I'm gonna build. I'm gonna go back in Unreal, and I'm gonna here in the bucket right click and create a blueprint based on this class, putting it in third person blueprint. I'm gonna say bp_bucket and create the blueprint class. And ta-da, we have a box as the root component. Okay, so what I can do is I can put it here, and because I can, I'm gonna override in the editor some of the scale of the box component. So I'm going to grab the box collision, and in the shape, and you can see it's not editable anywhere, so I cannot have access there to the parameters. So it's a good sign that I need to make it a uProperty, edit anywhere. So I want to edit it anywhere, and blueprint read write, and the category will be components. Let's build again, and you're gonna see that now I will have access even in the level, or at least I should. Oh, you remember also when you do that, meta allow private access equals true, because it's a private variable. And now, by magic, we have access to the box collision and its shape, and we can make it a bit bigger, like this, and we can place it where we want, on top of this, Okay, so if we want now, what we can do is we can press Ctrl E to edit, and you will see that you will have a component called text render, and if you look at that, it's a text render component. So that's exactly what we're gonna add, but this time again in C++. So we're gonna add class, because we want to forward declare it, uText component, render component, and this is going to be a text component, or text comp. I'm gonna do the same thing, but this time I'm just gonna make it visible anywhere, and only read only in blueprints. And on the other side, I'm going to make the text component, create default subobject, and I'm going to simply name it text comp, and I'm going to attach it to the root component, which is the box collision. Okay, so setup attachment. Again, a text component like this, and of course uText render component, and I need to include the component. It's actually, I don't know why, but it's not giving me the right place. As you can see, it's still in components. So here it's in component. So if I compile, and also what I want to do is I want to change the text by default and say set text and say hello. And I also want to make sure that the alignment, horizontal alignment, is center, and the vertical alignment of the text is also to the center, meaning that the center of the text will be the pivot point of the text, which should be much better. Let me build again. I don't know why I have only one log. Okay, I'm gonna close the editor. I'm gonna save everything. I'm gonna restart the editor. So I have an error, and what error it is because it's probably not a text, set text, expect a f text. So f text, and it expects a string. Does that work like this? Because again, f text is the internalization way of working. It means that we can translate every strings that are in the engine written as f text. So apparently it's not working. Cannot access a private declared in class f text. So should I put a f string in the constructor also of the f text? Let's try to build and see. It's strange that it's not building properly when I press Ctrl B, but let's check again. What's the error? Cannot access private member declared in the class f text. So apparently the uText render component is not found, which is strange. Text render component. No, it's the case. What is going wrong there? I'm creating a default sub-object of uRenderText. I'm for declaring the object. What's the output? It's really linked to the text. So let me try to do f text text. Let me try to do that, but it will be easier to read with the number of parentheses. So if I want f text, can I do from string? From string? Yes, I can do from string. So I can return using the static value f text from string. And let's say hello. There are lots of utility functions in Unreal for that. Let me restart the editor while building. And I do think I need to restart also Visual Studio because there is something quite strange with that. So uText, a render component, the vertical alignment apparently is not happy. It's a E horizontal text alignment. So E horizontal text alignment, and what's its center? And here it's E vertical text alignment, and it's probably text center. It's probably better like this, right? And if I compile and run the editor with Ctrl F5, now it should be working. It's working, it's actually running the editor. And if we look at the component, you can see that we have indeed hello being written over there, okay, which is quite nice. This will be the bucket that we can align here on this platform. Let's press Ctrl and go on the top, and F to focus on this object. Okay, so we can move it to the center. And I'm going to reduce the extent to a cube like this. Okay, Control and middle click down to the corner, the right corner. Okay, so I have this object that actually does nothing, but what I want to do is when I drop an object in it, what I want is that the text updates to a count, okay? But before that, I'm gonna enter into the blueprint, pressing Ctrl E. In the viewport, I'm going to grab the text component and I'm going to put it a bit higher like this. And I'm going to change the text to 0 over 2. But before, what I want to do in the bucket is I want to have a property that is an int32, okay, and this is going to be called max amount, or yes, max amount, okay. It's going to be 2 by default, and I want here to have an interpolated string, so I'm going to use fstring printf, and I'm going to say what's the current value? 0 over the int, okay, and the int, and it's going to be a text, sorry, inside, and then I need to do the max amount like this. So if I do that, and if I build, I should be able to, so I've lost syntax highlighting, I should be able to see the text updated. As you can see, it's now 0 out of 2. Okay, so our goal, as you understood, is now to check the collisions with the cube. So when we grab the cube, and I don't know why we cannot grab the cube anymore, and it's probably linked to, that's strange that we cannot. Let's move. Oh, yes, we can now. It's probably a compiler issue. And then when we go, we should update the counter. So what we want to do is to actually, in C++, react to the overlap event and the end overlap event. So begin and end overlap event. So in the bucket, what we're going to do is we're going to bind to an event that exists, and that is called a delegate in Unreal, and we're gonna say box collision like this, and we're gonna do that in a function that is called post properties, as you're gonna see. So post init properties. So I'm gonna override in actor. I'm gonna override on post init properties. It's when the post initialized component, sorry, that's the one. It's when all the components are initialized. We can at this stage bind to a delegate from the box collision. Okay, so it's just after the constructor if you want, and then we are going to say on overlap, and it's going to be on component begin overlap. And as you can see, if I press Ctrl and click on it, it's an object of type delegates, and this delegate, if we look at it, f component on begin overlap, it's defined, if I control click there, over there, as what we call a multicast delegate. So delegates are functions. So they are not functions, but they are function definitions over there. And as you can see, they can take parameters. So we can expect a delegate to have some parameters that are defined using this strange macro. Okay, and you can see that this delegate has 6 parameters. Okay, because it says _6 params. And as you can see, it brings different information about the components that we hit, and etc. etc. And in the actor class, we have the onComponentBegin overlap delegate being declared over there, and it's also blueprint assignable. Therefore, if we go in any blueprint, you will be able to override this. If we go there, for instance, in the bucket, in the event graph, we can see we have the actor begin play overlap. Okay, but what we want is us in C++, we want to bind to this one. So what we can do here is we can create a function that is called onBegin overlap. This will be a U function. It's very important to mark it as a U function, otherwise you cannot bind to the delegate a function that is not marked as U function. It's really important. So in post initialize component over there, what we're going to do is we're going to grab the box collision, and we're going to say onBegin component overlap, and we're going to say add dynamic, but beware about the IntelliSense, because it's going to propose you internal dynamic and you don't want that. What we want is add dynamic. And on which is the function that we're going to bind? It's on this object, and it's called onBegin overlap. And it's on the A bucket like this, and we need the address of. So onBegin overlap, it's there, but of course the definition is wrong. We need to paste the parameters that we've seen in the definition of the delegate, because this is what, when we're binding, the function is expecting as arguments. But you can see that we have an issue, because in the macro definition, they are putting a comma between the name and the type. Okay, so we need to remove the comma just after the type of each parameter. And remember, we had 6 parameters. Something like that. So now we can generate the implementation. And here we can add a debug screen message, let's say bucket overlap. Let's build and see how it works. Apparently the build was functional. And if we go there, I just moved off screen, off record, I just moved the box near so we don't have to walk for hours. I pick the box, I go there, and apparently it's not working. Okay, let's see why. I'm grabbing the box, and the box collision there we have, let's reset the collision preset to overlap all dynamic, and just make sure it's working. And you can see that here it works. So we can overlap with the object, but you can see that we can also overlap as us as pawn, which is not the best idea. So what we can do, and that's quite easy to do, we have multiple solutions of course, but one thing that we can already make sure is that here, if the other actor dot get class dot implements interface u pickable interface static class like this, and we need to include the pickable interface. If this isn't the case, then we should return. So we make sure that only pickable objects are able to react to the overlap event. So if we go there, you can see we don't have any events, but if we pick and we drag the box there, we have, as you can see, an overlap. This is quite good. So what we can do is we can have a very similar approach with the other function, which is that we need to bind, which is onComponent and overlap. And if we look at the signature of this delegate, you can see that it's a bit different. Okay, so we grab the definition there, or at least the parameters. We come back and we add a new U function that is called onEndOverlap. We can call it the way we want, but here let's call it like this. We pass the parameters and we remove each time in front the comma like this, and remove also the argument. So we should have, if we're not mistaken, we should have, let's grab the definition again. It says it's 4 parameters, so we should have 4 parameters in our function. So 1, 2, 3, 4, 5. So we are wrong. So the first parameter, we need to remove it, of course. 1, 2, 3, 4. We have 4 parameters for the end overlap. So let's create an implementation for that. And here, let's make sure that if we are not implementing the interface for the other actor, okay, here we can say bucket end overlap, and let's put it red to make the difference, and let's call the end overlap instead. Let's bind, sorry, to the end overlap. Okay, so it seems to be working. If we play, we should have bucket overlap, end overlap. Okay, so we can see how this works. So now what we can do is, of course, we can have the count reacting to that. So, and it's as easy as saying count, as adding, sorry, a current count. So current count, at the beginning it will be 0. And here we increase it. Here, when we go out, we decrease it. And of course, we can extract this probably as a function, this whole section. So let's Control X, let's create a new function. In the private section, we're going to say update text count, like this. Let's generate the implementation. Let's paste everything, and for the first parameter, we're going to interpolate it with the current count, like this. We first start by updating the count in the constructor, but also each time we increase and each time we decrease. So let's build. And if we come back there, we have the count increasing. Okay, if I grab the other one, you can see we have the count working. Okay, and it's working real time, and it's great because we now have something cool, which is the platform working quite well. Okay, so now the last thing I want to do to show you actually is, let's use this this platform and let's add an event when the platform is complete to signify that we've added the object to it. Okay, so that will be an event, a custom event that we've done to signify that this platform is full. Okay, or at least was once completed. So in order to do that, we're gonna create our own delegate. So in order to create our own delegate, we're gonna declare it here. So we are gonna say declare, and now we have multiple possibilities. A dynamic multicast. A multicast is when you have multiple functions that can be bound to the delegate, so to the event. So you have multiple functions responding to an event. And dynamic means in short, that you can use it using blueprints, and that you can bind to it with blueprints. And you also have other type of delegates, so you can only bind if you want a dynamic delegate, which is a delegate that is only that is not multicast, so you can bind only one function to it. And you also have the variants with, as you can see, the number of parameters up to 8 parameters or 9 parameters, as you can see. So in our context, what we're going to say is we're going to say one param, just as an example. Okay. And the one param is going to be a string, so we're going to declare first the name of the delegates. So this is something that we can indent there, and I can say bucket completed, and then we can say we can add one parameter, so it's going to be a f string. So we first put the type. With dynamic multicast delegates, we first put the type, then a comma, then the name of the parameters, and we're going to say, for instance, message. So the dynamic multicast is going to send us a message. Okay, and I put a semicolon at the end. So now I can let's usually I like to call them on with the f in front, like this. So here in the private section, or at least I'm gonna put it, yes, I'm gonna put it in the private section for now, and I'm gonna say on bucket completed. What I can do is also expose it. I'm gonna do that later, but just to show you, here I'm gonna say if the current count is greater or equals to the max amount, then the delegate, I'm going to broadcast it. And broadcast means that I'm going to emit the delegate, so everybody that is connected to it or bounded to it will receive the signal and will execute their own function bound to it. So here I need to pass the f string, and this is going to be the string of the bucket. So I'm going to add a simple string corresponding to the bucket. So this is the bucket message. I'm going to make it a U property that is visible, editable anywhere, edit anywhere, blueprint, read write. Sorry, and the category, I'm going to leave it in the default one, and I am going to put a default message, and I'm going to use that as the string that I'm going to pass as the argument for the broadcast. Okay? So now what we can do is we can expose this delegate to Blueprint. So in Blueprint we can bind ourselves to it. So we can say Blueprint assignable, okay, and also visible anywhere, something like that. And if we build, you're gonna see that, oh, I have an issue, should not be used on private member, so I'm gonna put it in protected section, and it should be working. Should not on private, so maybe I should add the allow private access equals true, even in protected, because of course this is private in the sense of Blueprint. Blueprint read write should not be used on private member. Once again, allow private access. Yeah, that's strange. I should be able to do that. Not the, oh, sorry, not the read write. Read only. there also. Let's do this meta over there. Sorry, that was my mistake, I think. Yes, it's working. Okay, so if I go there, I look at my container in the default section. I have the default bucket message that I'm going to override, like say north bucket is filled, something like this. Okay. I save, but nothing will appear because we are not listening to this bucket, to this delegate. Sorry. So I'm just going to put more boxes nearby so we have the possibility to fill it quickly, and I'm going to also grab my character start and push it forward so it's faster. Okay, so now if I want to bind from another object to this delegate, I need to have a way, of course, to access this this delegate. So it's very bad, but this is just for us to prove that it is working. But I'm going to do that in the level blueprint. So I'm going to grab the bucket, select it, open the blueprint level, and if I right click, you can see I can have a reference to the BP bucket. This is very bad, okay? Usually you don't do that. And I'm going to show you probably the proper way later on, but it's just for showing that we can bind. And we want to bind on bucket complete. And you can see that here we are binding. We are having a box that is the bound representation, the binding representation of this event. And what we can do is we can get the begin play, and on begin play we're binding to this event. So each time a broadcast will appear, this box will trigger this event. So we can drag a line there and add a new event that will be custom, and this is when the on bucket completed. Okay, and we have a message there. So what we can do is we can print the string just for fun, and you're going to see that this should work. It's very bad practice again doing it like this. We're going to do it proper after we have proven that it's working. And put in one box. This is going to fall. One box, putting two boxes, and you can see I've seen the sentence was very short, so let me bring more time to it and a sort of yellow color, but I've seen the message of this container. So I'm putting a box there, putting a second box, and you can see instantly North bucket is filled. Okay, so that is actually working, but as I mentioned, it's quite bad. Usually you don't go with the level blueprint like this. So what we're gonna do is remove that, and we are going to go in the game mode, and in the game mode we are going to store all the buckets that we'll have in the terrain. This is going to be a bit more clean, not saying that it's the best way of doing things, but when it starts to play, and we're gonna even do that in the begin play. So implementing begin play. Start play is just, I think it's before begin play if I'm not mistaken, so I'm going to remove it, put all my code inside begin play this time. Something like that. And in begin play, what I want is, I want to store, I want to get all the buckets. Okay, so if I have multiple buckets in the scene, which is the thing that we're going to do, so let's add another one. That is going to be, I'm going to duplicate basically all this thing, put it there, and I'm going to say that this is the the sentence will be south. South bucket is filled. I'm gonna save. I'm gonna come back there, and here in this game mode, in begin play, I'm gonna have an array of buckets. So I'm gonna do a T array of type bucket. So a bucket, and this is going to be an array of pointers. Okay. And I'm going to forward declare the aBucket class, of course, and I'm going to say buckets. So this is a container that is an array, and a specific one from Unreal. We're not using the standard library of C++, we're using an array that is prefixed with T. Okay, like this, and you have the same functionality where you can push, you can remove, you can iterate on top of them. But those are taking into account memory management in a better way, and they are more Unreal friendly. So, and the buckets, we are going to fill this array at the begin place. So we're gonna get the world and find actors. Okay, so it's not in actors. There is probably. So we have, yeah, not in getWorld, we have uGameplayStatic, which is a sort of static library, like a library of static functions. And we should have, if we search in it, we should have get all actor of class. Here, you can see it. It's a function that returns all the actors of class type. So that's what we're gonna do. So uGameplayStatic, like this, get all actor of class. The world context object, this time it's the context object that is so inside the world, so we can probably get the world. I hope that, so let's store the world inside the pointer, so we can this time check the world. It's important to check the pointer, but it should be fine. Just to avoid a crash, I'm going to do it in any case, but it should be fine. Then we have the actor class that we need to actually find, and we probably can grab the static class reference from aBucket. This should work, and the out actor should be bucket. And as you can see, it's not casting to real buckets. So what we're gonna do is, okay, first let's do early return. So here what I want to do is still have an array that is of a actor type, like this. Instead we're going to do that. And let's first check if we can fill for each of the actor found. So a actor found actor inside the found actor array. So this is a shortcut in C++ where you can iterate quickly on all of the objects there. So each time I'm gonna get found actor that represents an actual actor that was found, and here I'm gonna cast this object and add it to my own bucket list. So I'm gonna say bucket list dot add, and I'm gonna say aBucket. Here bucket is a cast of this actor. aBucket is a cast of this actor, and if the bucket was actually, we were actually able to cast this actor to a bucket, then we add to our bucket list the bucket. Okay, so we should be fine. And in the end, what I want to do is a simple UE log saying that buckets found and the number of buckets that we found. And this is simply going to be the buckets dot num, which is the size of the array. Okay, so I'm going to build. Hopefully this is going to work. I forgot to introduce bucket.h, so let's add that. Let's rebuild. Apparently it works. And if I go there and start the game, in the output log, we see that we found 2 buckets. Okay, pretty good news. Now what we can do is we can actually bind to our delegates. And we're going to bind exactly like we were binding with the onBegin overlap. So it's super easy to do. Again, when we add the bucket there, what we want to do is let's create a function that we will be called. So again, it will be a U function. So U function, and it's going to be bucket completed on bucket completed, and it's receiving an F string, which is the message of the bucket. I'm going to create the implementation of this. And here, once we found the bucket, what we're going to do is bucket dot on. So let me bucket, sorry, dot on bucket completed, add dynamic, and we're gonna bind to this event on a function that is on this object, meaning the game mode, and we're gonna say we're gonna put the address of this function, which is on bucket completed, like this. Okay, so binding to all the buckets to this function, and here what we can do is we can add a message on screen, which will be bucket completed, and the message will be message, for instance. And we need to dereference the string because we are expecting a C-type string. I'm gonna build. I have an error. U function. Small typo. And here cannot access private member. Okay, yes. The delegate was private, so you know what? It's easier now to put it public. Even though sometimes it's better to have a public function that grabs the objects and internally bind the delegate to the object that was passed. Here I'm gonna choose the simplicity, the simple version, and make it publicly available. Let's look about how it works. So now it succeeded, and what we can actually do is test, but I will need to be smart enough in order to fix this puzzle. That is not actually a puzzle. Let me reopen the map. Sometimes it's buggy, yes, regarding the locations. So if I play, okay, 1, and as soon as I will complete it, you're gonna see the message bucket complete, north bucket is filled. And now if I grab those, 1, 2, bucket complete, south bucket is filled. And the great thing with that is that we now have some gameplay elements and gameplay systems that we can actually duplicate very easily. So as you can see, I can grab this and as the platform and put another one there, and I can tweak the very easily. I can tweak the bucket, and I have nothing to recode. Okay, and it's quite efficient. Okay, so if I do that, you can see other data, blah blah blah, and you can see how easy it gets for us to start creating some gameplay logic. Okay. So of course here it makes no sense because I can complete it, but I can after remove and it's not complete. So you can see how you as a student, you can start introducing new ideas and new gameplay features with this base. I highly encourage you to pursue the prototype that we were actually building together. I do think it's really important. Don't hesitate to post a link in the comments of your gameplay. But we're gonna stop there on this video, and maybe later on I will be able to do other videos regarding Unreal. But what I think I've done in this video is presented you with like good practices for game programming, or not good practices, but at least giving you some clues on how to get your hands on the engine and to start discovering by yourself, or at least reading with some documentation and some forum posts to start getting a better idea on how the engine works. I know it was not beginner oriented in the sense that you should already have some basic C++ knowledge and some programming knowledge, but I thought this was sort of missing a tutorial similar like this. So I hope you enjoyed it. I know it's quite long. You probably haven't done that in one run, of course. And I hope to see you soon in another video, and thanks for listening, and have fun discovering this engine that is quite magical, and hopefully you will be able to develop great games in your future Unreal development career. See you!